There is no triangulation in celestial navigation. So it is actually triangulation. There is no triangulation in celestial navigation. So it is actually triangulation.
With celestial navigation using a sextant, we're not triangulating.
So it is actually triangulation to the GP. So you can draw it on your chart, draw a line there, and then you do it for all three, and you get your intersection. So it is actually triangulation. There is no triangulation in celestial navigation.
With celestial navigation using a sextant, we're not triangulating.
So it is actually triangulation.
Are you serious? Are you
The double-speaking McBooger-eating, ball-tard bum-sniffer wouldn't know what the sextant or celestial navigation were if they climbed up his arse and started kicking footballs wrapped in concertina wire.
Just when I think you couldn't possibly be any dumber, you go and do something like this. And totally redeem yourself!
I think the sun is a physical object, and I think it is solid enough.
What the hell did you just say?
I think the sun is a physical object, and I think it is solid enough.
Say what?
Yes, a gas giant bounces radar.
How in the world can a
Gas giant
be
solid enough? So yeah, I don't know.
you dumbass cracker?
You are so dumb. Damn.
And we're off. As usual, if you'd like to support this channel, there are PayPal and Patreon links in the info box below. This is gonna be a hastily contrived show today because I had a change in plans. Number one, shout out to Betty. She's not going to be here today. She has sort of an emergency, and I'm with you there, Betty. You hang in there. So she has an excused absence. And the other one is I was about to do Nature, the scientific method, natural science and the scientific method. Sorry, I falsely advertised that when I ran into a video earlier this morning. I decided to change that up and deal with this from McBooger Eater. So it's going to be, there's going to be a lot of this and that and what have you. Well, hopefully Adam's in there. I haven't looked at him, and I got you guys still on mute. I'm trying to explain this to these guys out here so they know what direction that we're going. We're probably going to be over talking each other a little bit because this is just purely off the cuff. But I couldn't let this by. The reason why we're doing it is what happened is Jaron and McToon had a little so-called debate. It popped up in my feed. I listened to it. I said, oh, my God. And we did a review on it on Nathan's channel. Now, we demonstrated that Jaronism, being out here for 8 years, leaders of the flat earth, is an absolute fraud, numpty dipshit. That's not what we're doing here today. What we're doing, we're evaluating now McBooger Eater's mindless parrot of the retards, Reds Pretenderic, and Astronomy Live back in the day. Because I remember this idiot proof way back there, whether it was 2015, 2016, it was in the 2016, 2017 area. You get the picture. And I didn't remember it all that well, but McBooger Eater brought it up. and he was mindlessly parroting his proof to Jaren because he knew he could get over on Jaren. I mean, an idiot first grader can get over on Jaren, right? But like I said, we're not going to be evaluating Jaren's performance, maybe just a little bit, but that's not the focus of this exposition. It's going to be the train wreck idiot proof, not only of the mindless parrot, which he doesn't have a clue, but Red's Pretenderic and Astronomy Live, those two retards, their performance. And by the way, there's going to be another evaluation coming up with Red's Pretenderic and Astronomy Live with their distance to the sun. This was a recent development. See, I thought Red's Pretenderic wasn't even on here anymore. I thought he was gone, but apparently he's not. But these two idiots went and did their friggin' schnoz particle shift ordeal with the distance of the sun. We're going to get to that. If Nathan doesn't get to it by next Tuesday, then we'll have to do it here. But I just want to lay the groundwork on what's going to happen here. So, like I said, I watched it this morning. The reason why is because I didn't watch the original McToon Jarenism video just a couple minutes before I turned it off. It was stupid, right? But while we were evaluating it on Nathan's channel, I couldn't see in the after show. You can't see, the people in G Plus can't see the screen. So we were just listening to the audio, and it was hard to pick up what was being laid down. And Nathan released that video, whether it was last night, or I think it was last night or early this morning. And when I woke up this morning, I clicked it on. I was doing other stuff, and I was just listening to it. Then I walked in, and I looked at the screen, and I couldn't believe what I saw. It was something like this. Oh, stop. It was something like this. That's what I did when I looked at the screen. And I said, okay, let's can the natural science and the scientific method, and let's deal with this. This is so incredibly stupid. You guys aren't going to believe it, but we're going to go over it. So you guys squared away now? You for sure on what's going on here? All right, I'll open up the lines. Hopefully Adam's in there. Adam.
Yes, sir.
Aha, he's there.
I assume then I'm on super chat duties as well.
I was just going to tell you that.
I'm on it. Have you noticed, right? Since in Holland or the Netherlands, the Dutch Farmers Union have come to power, his time has been much harder to get hold of. I wonder if she's heading for Parliament.
No.
The emergent.
No.
If not, I wish you the best.
Yeah, this is a sensitive situation. Like I said, shout out to Betty. You're not alone. I'm with you there. You guys don't need to know what it is, but she knows.
Matt, don't need to know to send her our love. So,
yes. Yes. It's an authorized excused absence. That's just what it is.
So hold on. The question is Adam sharp today?
Oh, Adam sharp.
Okay.
So when we're going over this video now, you got to understand something. They're using elevation angles. We know that these booger eaters can't use elevation angles. The whole argument's in the trash. We already know that. Number one. Number two, the fairy tale ISS is supposed to be in a 10 to the -6 torr vacuum. Well, that's a second law of thermodynamics violation, so that can't happen either. So in lieu of those two and others, we're going to take a look at McBooger Eater's mindless parrot, and we're also going to evaluate Red's Pretenderic and Astronomy Live, because that's who he's mindlessly parroting. He screenshotted some things, and he's going to use it as a proof against the numpty Jaren, right? You could bring a first grader in. It wouldn't matter. Jaren he'd fumble and bumble and stumble with it, right? We already established that. That's not why we're here today, right? We're just here to evaluate what went on, essentially McBooger Eater's presentation to Jaren. Got it? Yes?
Well, I do, obviously.
Can I get an amen?
I give you an amen, brother. What? Yeah, there's levels in there. It's like QE starts it off, and I'm going, yeah. And then it gets a bit annoying because I don't understand it, what they're claiming mathematically. And that's probably what I want to go into the... I don't even know how to describe it.
I know.
Fantasy mismatch.
I have no idea.
Complete miscomprehension of terms and their meanings, and how you can hybrid these things together to conjure a number. Is brilliant.
Yes, sir.
Nathan, by the way, has arrived and says we may begin. So.
Yeah, I know. I seen him out there. We may begin in my travels here. I got you. So I guess
I hope that PC's bearing up. I hope she's... Well, she's not. Nate, he sent me some screwy pictures. It looks very poorly. My technical opinions.
Let's
can't even manage a picture now.
Let's shout out to Brian. Brian's in here. What's up, Brian?
Hey, QE. Hey, Adam. Hey, everyone.
Boy, you're loud.
I am?
No, maybe it's me. No, that's a bad thing.
You tell me when you want me to talk then.
This is going to be a two-man team. You can barge in. If anyone's going to barge in, please, because Adam and I can already anticipate that we're going to be talking over each other in some instances. All right? I'm already warning you about that because it's just the nature of the beast. We haven't had time to get our feel for it, right? I know what I saw, and I guess he watched it earlier, and he knows what he saw. So now, if you're going to barge in, I want you to be concise. I want you to be, not only you, Brian, anyone, that anyone bumps in here, I want you to be so concise it cuts the audience with a knife. You understand that?
Yeah.
Okay, I'm going to barge in real quick.
I'm going to barge in now.
Hold on. Can I say something? That means if Adam cuts in, we got to realize that he's doing super chats. Shut up.
Thanks, Neil.
That's one of my many powers this evening. Yes.
No, but we got to be sharp too. We got to. If you're saying, "Hold on," we got to know as a crew. He's got a super chat. Shut up. At least I
should
will.
know if I'm over talking you and interrupting you. There's a reason, anyway.
Okay, what we're going to do with super chats, we're going to wait until we're finished with the presentation. It's not going to take over too much time. So, Adam, do not interrupt. If there's super chats, we'll get to them at the end. Okay? Maybe not. I'll take that on board. Can you take that on board? Thanks. Okay, I got it shared. I hope I didn't forget anything. There was a lot of things happening here. I almost came in here late. I'm trying to get my act together. But we're here now. I'm sharing it in Discord, and it's going to be shared to YouTube in 1 second, I think. Let's see. Let's get this squared away.
Can I throw a spanner in the works before it gets started?
Tell you what. What?
Well, from what I saw of what they did, there's two ways to do what they were trying to do.
Just a sec. Super chat interruption. Russ Bonanno. $5 super chat. Thanks, Russ. Test. I think that test worked. Russ, thank you very much. You're a gentleman. I appreciate the irony of that. Ryan, over to you.
Got it.
Go ahead, Brian.
There's two ways to do what they were doing on the globe, right? Using a globe, there's two ways to do what they were doing. And they didn't use any of the two. That's all I'm going to say for the moment.
And you're going to barge in because they're using angular size, and they can't do that on a globetard. I understand. We got that part, Brian. I know you're going to barge in and say that, and you're exactly right. But in lieu of
talking about that.
But you will be talking about that once I put this on.
Oh, yeah.
Let's try and keep the comments pertinent to the bit of video that we're playing, because there is so many things. We'll go through them via the video if we can, because that'll be, I think, more productive. Because I've got. It's only like I had a look at this afternoon, QE. So have a look, and I've got 2 pages already. So, you know, let's let the video guide us.
Because I can't believe it. I listened to the first time and I came up with the phrase, and Adam lost it. It's the not actual size degree pixels. So just remember that phrase, the not actual size degree pixel ratio. That's the complete thing. Not actual size degree pixel ratio. All right, that's all.
It's the ratio. It's the master stroke. Yeah. It's just a leap forward. And I'll be honest, I do try to use that ratio later. Try and make some sense of this, but the way they use it is just.
Yeah. Okay.
Digitation.
Okay, we're going to do it. Okay, here we go. Wait a second. Let me turn this up. 1 second. I want to make sure that that McBooger Eater's being heard loud and clear. Turn those up just a touch. That should please Nathan. All right. Where are you? There he is. Okay, go ahead.
This was just because, like, I know Brian will want to make points. Cool. But also, if you're not understanding what we're taking the mick out of, please just ask. Don't go in for a waffle. But if a point needs reiterating as to why it's nonsense, because this is high-level bullshittery. McGoons in here. And as you can see, I'm not having a go at Jaren, but you can see sometimes if you don't understand, it's polite to nod. Yeah? Or not show your ignorance is the point of that. But please do. Because I've had to rewind and pick through this because it is high, it's good quality high level bullshittery.
This is some stupid shit we're getting ready to hear, folks. By a mindless by a retard McBooger Eater. He's the McBooger Eatingest McMoron this side of the McWest. So just prepare yourself, right? And just take it in. All right, here we go. Get ready for the over talking by me and Adam.
This is his elevation of the ISS measurement.
So this is the elevation of the ISS measurement.
And I don't know if you've gone over this. It involves a little bit of trigonometry. This is about high school level.
High school level trick that you would know nothing about. You would fail. And we're going to show you how you're going to fail. You're just posturing like you know what you're talking about. When we all know that you're a McBooger Eater. And you're going to show everyone here over the next few minutes.
Trig. And of the, I hope that this isn't.
We can't hear in Discord, or I can't.
You can't hear him.
In Discord.
It's very low. It's just low for me now. I can hear it, but it's low.
Always a problem. That's from Jaren not turning his mic up. McBooger Eater's mic up. 1 second, folks. Let me see if I can't work a little magic here. Adam, you're going to have to turn this up.
I'll crank it up in here as well. I couldn't hear a thing there. I don't know if Brian's picking a bit up cool, but...
You're going to have to turn it all the way up. Jaren's going to blow your ears out when he interrupts. But this is just nature of the beast. Everyone out there in YouTube land's hearing it.
How else is everybody else in Discord hearing it?
You're great.
Turn me up full blast.
Yeah, it's really loud in here right now.
There's a separate volume for live streams. You have to right click on the live stream to get that.
Oh, do you? Adam, do you know where that is?
Thank you very much. I'm at 100% now. So thank you. I was at 70, so hopefully that'll help.
All right, I'm gonna turn it on, Adam. Sorry for these small technical difficulties, folks. Thanks a lot, Jaren, you moron. Another thing. Let's go ahead and put him back on. I'll let it play for about 5 seconds, Adam, and then I'll ask you if you're dealing.
I think if you don't use Trig, it gets super rusty.
I'm
I
all
get
good.
that. I would.
You're all good. All right, we're ready to roll, folks. Mr. Trigg.
I just want to interrupt here at this point.
Go ahead.
That's a claim, isn't it?
Yep.
If you don't use trig, okay, so that's a definite claim. What we're going to do, so we're going to measure things using trigonometry. So
Yes, sir.
that makes sense.
Here we go.
I don't expect people that don't do trig to get it, but
You don't expect, yeah, like you. You don't know what trig is. You don't know what triangulation is. We just listened to a video or to an audio that you are clearly clueless. So you're just putting on an air. You're posturing. You're a fraud because you don't know it. Idiot. Dumpster fire.
But saying it's not right just because you don't want it to be right, of course. And
Just saying it's not right. Well, we haven't said anything yet. You haven't presented it. So no one's saying that just it's not right and hand waving, dismissing. That's not what's happening here. We're going to tear your ass right through your throat systematically. You clown. I don't even know why you're still out here. Remember the signature numpty clips? Where I eviscerated your dumb ass on no less than 25 points? I mean, really basic points. So, I don't know. You're delusional also. We'll continue. I digress.
Jaron, I'm not saying you did this, but
shut up.
That's not the correct way to have a response to this either. So
shut the hell up and get on with your train wreck dumpster fire that you're parroting.
Anyway, this is simply screenshots from this video. This is the diagram of what he and Astronomy Live did. You'll see that
this is from Red's Pretenderic in Astronomy Live. That's what he's talking about.
The angles A and B are the same amount. This does not use the distance to the moon.
So we're not using the distance to the moon
at all. It only uses the angular size of the moon. So don't be.
So that we're only using the angular size. That's the not actual size of the moon. That's what we're using. The not actual size of the moon in trigonometry. You can already see this is going to be a train wreck, epic train wreck disaster of a dumpster fire.
And it also doesn't use the actual diameter of the moon.
Well, that's redundant. You just said we're only using the angular size. The angular size is the not actual size or the not actual diameter. Folks, he is absolutely friggin' clueless. Absolutely clueless.
So no specific information about
the diameter of the moon comes from the angular size.
Thanks, Brian.
It's just the angular size of the moon.
Yeah, just the angular size. You said it 3 times. The angular size, meaning not actual size. Look up angular size. That's what it means.
0.52 degrees.
Really? 0.52? Go ahead.
I think I've just read in chat and Nathan's just popped in, so I assume, Nathan, you want to tell us?
Yeah, he's just too quiet. It's Jaren's fault, strictly speaking, because he's leveled up Toon so badly and he's 10 times quieter than Jaren. You're just going to have to turn him way up. But you can't hear him in the live stream hardly at all.
Well, I can't turn him up. Hello? I can't turn him up. I can't turn him up.
You could put on the subtitles.
You turn him up on the line on. Turn him up on banana.
I can't turn him up on banana.
Why not? Well, I'll leave it to it. Whatever. You just can't hear it in the live stream, just so you know.
Yeah, thanks. Freaking Jaren, you numpty dipshit. That's okay. We can hear him in here. They just won't be able.
As Brian suggested, just press the CC button, put the subtitles on, and that might help.
Okay, let's roll back a little bit. That might help. I'll repeat as much as I can. Let's roll back then. Here we go.
And even if I say, don't just believe me. You should definitely be checking things out for yourself. People still will, and I know that flat earthers do that. So as well. So the tables goes both ways. So I have done things myself. I prepared This is not something I specific. It goes straight to that point. So is the timer going? I can't see it.
Go ahead. No, we got 5 minutes.
Okay. So this is from Res Rhetoric. This is his elevation of the ISS measurement. And I don't know if you've gone over this. It involves a little bit of trigonometry. This is about high school level trig.
Mhm.
And of the, I hope that this.
Like I said, which he clearly is clueless of. He's talking about high school level trig. He's trying to put on the air like he's some trig god that he knows trigonometry. He doesn't know his ass from a pipe wrench. He's just putting on the air, you friggin' fraud clown. Much like this idiot.
This isn't too far for most people. I think if you don't use trig, it gets super rusty. I get that.
You don't use trig. You don't know what trigonometry is. I just showed in the beginning, like I said in the audio, that you have no idea what trigonometry is or triangulation. Idiot.
I wouldn't expect people that don't do trig to get it, but
yeah, like you. You don't get it.
But saying it's not right just because you don't want it to be right, of course.
Saying it's not right just because you don't want it to be right. No, like I said before, no one's doing that, you friggin' bozo. God,
I hope we're going to just honestly analyze what's presented to us as reasonable conjecture of how you can measure these things.
Yeah, mindlessly. Mindlessly parodied, presented. That's what he's going to do.
Yeah, I think that becomes apparent that it's not presenting your own ideas, it's presenting someone else's.
Oh, God. Adam!
I know. Well, there's number one.
Relax.
This video, this is the diagram of what he and Astronomy Live did. You'll see that the angles A and B are the same amount. This does not use the distance to the moon at all. It only uses the angular size of the moon. So don't be.
So again, before we were rudely interrupted, we're only using the angular size of the moon. That means we're using the not actual size of the moon for our trigonometric functions here. That's what he's saying. He's that much of a doofus.
Also doesn't use the actual diameter of the moon.
And again, he's being redundant because the angular size is not actual size, so it can't be the actual diameter. That's how stupid he is.
So no
specific
information about the distance.
It's important that angular size is understood. Yeah, we're not measuring an angle to the moon. We're expressing its size in terms of degrees in the sky. It's still a distance. It's a non-scaled distance. So all we can do is express it in degrees. That's what he's making a statement of. Yeah? Make no mistake about that. What angular size means, it doesn't mean an angle to anything from you. It's just how much angle, how many degrees it's taking up in your field of vision.
Yes, sir.
Representing a distance that you can't know because you've not got a scale. All you can do is describe it as an angular size. I'm done.
Thank you.
The size of the moon are included in this. Just
I was going to say something as well.
Which?
Go ahead.
Yeah, I will. Because I have to say it. I can't hold it in. Angular sizes can't exist within the heliocentric model because they are perspective measurements. And that doesn't exist within the model.
What did I tell you you were going to say? What did I tell you?
I know what. You knew I was going to say it. I can't let it go. I can't let it go because they're using perspective.
That
when
perspective comes up in a bit.
Yeah.
Let the video guide only comment on the shit that's been mentioned so far. That's all you're allowed to do. You can't add a bit till it comes up. It'll come up. Yeah. It's critical, that perspective bit, Bri.
But like I said before we started, Brian is exactly correct. I don't want to put it off to the side. I just want to put it into the place where we're talking in lieu of that. That'll be another one in lieu of, with the second law of thermodynamics violation and the elevation angles and the perspective in lieu of that, Brian. How about that?
You've not mentioned that, have you? Yeah, you see, you're not mentioned that because I got that warning. You're not allowed to mention all of the above because otherwise it destroys it before you get to it.
Before you get to it, and we want to get to it, Brian, because we want to dance on their graves and laugh at the booger eaters. Okay, you good? Okay, we'll continue.
So here is the simultaneous tracks that both Astronomy Live and Reds recorded as it went.
So guess what he did, folks? You had Reds Pretender and Astronomy Live. Reds Pretender was using P900, and Astronomy Live was using one of his Q36 Celestial 245 BR549 telescopes. They love the nomenclatures of these things. We'll get to that on another show. Fucking clowns. So you got two tracks. Astronomy Live is looking at this one over here to the left of the supposed ISS transiting the moon, and Red's Rhetoric 1.1 kilometers away from the other numpty Astronomy Live, and he's got his, right? And it's right here. Got it? So you got two different tracks of the ISS being superimposed on the not actual size of the moon. Everyone with us? Here we go.
Went across the moon. One of them was a P900 or P1000, and the other was Astronomy Live's telescope with the camera on it. Then they measured the actual height.
Okay, they measured the actual height. Listen to this. He said actual height. How can you get a non-actual size, angular size, from an actual height? Did everyone catch that, folks? Right. That's just one of the bugaboos in this train wreck. So he's got this green line is 962 pixels. We're back to the pixel game. This green line right in the middle, so they're saying the diameter of the moon is 962 pixels tall. That's their actual, not actual size. Everyone follow it.
It's important to note here that this is no longer in the field of how astronomers do things. We're now in the field of roofie digital analysis of picture world. Yeah, that brought us things like the Blackpool Swan, classics like that. So just put this into perspective. This next bit has got nothing to do with anything any astronomer would do to calculate these things.
Yes.
This is pure anti-flat Earth power or imagination.
Retardedness. We're doing pixels. So what he's going to do, folks, he's not going to take the pixels of the angular sizes, the non-actual sizes of the ISS. You see the tracks are right here, right? He's going to take the pixel ratio between each of the two tracks. That means the amount of pixels in between these two red lines. That's what this idiot Reds Pretender is going to do. McBooger Eater doesn't have a clue. He doesn't understand what's going on here. But everyone's got that, right?
We're assuming the pixel ratio of the two photos was exactly the same.
Yes.
Or there could be some disclaimer as to which photo they actually used to count the pixels on when they generated the overlay.
Yes.
Maybe just the overlay. But either way, that's a really valid point, remember?
Yep.
Which picture are they using here? We've got a
because
hybrid picture
they're using two different, like he mentioned, Reds is using the P900 or P1000. He doesn't even know. It's P900 because it's back 2016. And Astronomy Live's telescope. So he's telling you they're using two different measuring devices to measure not actual size distances. Okay? Everyone got that? Fucking idiots.
In pixels of the moon, and then measured the height in.
See, he said the actual height here when he says angular size, when it's not actual. So this is a built-in paradox? Moron.
Pixels of the gap between the two tracks, and then they get a ratio from that.
So you see what he did, right? He took the pixel height, the not actual.
Before we get to that, just the specific claim is he's got a picture of the moon from on one point and another picture of the moon 1.1 kilometers away with a different device. He's now overlaid to make a super picture. It's no longer a picture. Yeah, and it's now some I don't know, but we'll deal with that, right? Now what he's claiming is we're looking at the moon and we've got these tracks on the moon. We've not got tracks on the moon, have we?
No.
The tracks are not on the moon. The tracks are supposed, in their world, I'll step into Baller. The tracks are actually 500 miles away or 300 miles, 250 miles, whatever it is.
Yep.
Yeah? The moon is 250,000 miles away. Let's just put that into perspective when we're going to analyze these tracks on the moon, convert them into pixels, and then measure the distance. I think, is that where we're up to?
Yeah. So look at where he got his numbers from. Where Red's Pretenderic and Astronomy Live, you got the 962 pixels tall of the not actual size of the moon, and the 224 pixels between each of the tracks, the red lines. That's where you got, see, the 962 and the 224. He's going to get a ratio now of the not actual degree pixel distance. We're all up to speed. The not actual size degree pixel distance. Where we're going.
Right, 962 pixels tall, 224.
No, wait. The not actual size of the degree pixel distance of the tracks generated on the moon that aren't on the moon.
Yes.
Are the two different transits of the people 1.1 kilometers away.
Yes.
From the differential perspective photos. And that's what we generate this from, remember, perspective differentials.
Yes.
Important that. Brian Button. Go on, Brian.
No, don't do it, Brian.
Yeah, well, it's not about perspective. I'm just going to make the same point as I made at the very start. There's two ways to do what they're trying to do, and if you're using a globe, and they're not doing either of them.
Thank you, Brian.
We'll get to that later.
Thank you, Brian.
Pixels between the tracks, giving 4.29.
Okay, so he got his 4.29. So what's B? We'll get to it. Here we go.
And that 4.29, then they plug in, and there's no screen or no.
Yeah, there's no screenshot or anything. No, they just pulled it out their ass. Watch this, folks. Or listen.
You see, the more I think about this, the more I have to say there's a reason that left-hand side is obscured. And I'll come to it in a bit, because it should become apparent, and there should be no reason to hide it. But I'll hopefully demonstrate that there's a reason to hide this.
Yeah.
On, Kiwi.
Yeah, because remember, we got the 4.29, the not actual size degree pixel ratio. And he's taken, guess what, watch what he's going to do with it.
0.52, the angular size of the moon, and divide by 4.29.
You see what he did? Okay. He took the angular size of the moon, 0.52, and divided it by his not actual size pixel degree ratio, 4.29. That's what he did. And that's how they came up with
to get
this. Not 0.1212 degree pixel distance. Yes?
This is prestidigitation point. Yeah. I used it on Owen's show earlier. This is the switcheroo. Right? So if you proceed from this point without and go, right, that's fair enough. That makes sense from a geometric perspective, that we can take the angular size of the moon, take these two tracks, which are perspective based on where they go, based on these two people 1.1 apart, see where these tracks render when we composite the two pictures, calculate the angular size in pixels of the two tracks, and then comport this ratio into geometry in the picture that you're seeing on screen. This is the switcheroo. It's 0.52 being divided by this pixel this pixel. I'm sorry, this pixel ratio that we've derived from the composite.
The
picture.
not actual size degree pixel ratio, Adam.
It's so long.
It's the angular size of the moon divided by a portion of their computer screen. If you want to take it that way, that's what's going on.
The switcheroo I want you to realise, angular size.
Yes.
Has been divided by pixels. Now give you an angle, right? From which on the picture, you see where the ISS is.
Yeah.
Crossover point. That's the angle they've now calculated from the pixels based on the composite picture. Based on, say it again, angular size. When we look at the moon in the sky, it's an angular size, right? It's got nothing to do where the moon is, the angle between me and the moon. Yeah. The angular size is just how much space it's taking up in a non-defined system. So it's only a ratio of the sky. That's why I describe it in angles. Yeah.
Yeah.
That's all it is. It does mean fundamentally a distance. The way I describe it is as a percentage of my sphere of vision.
Yes.
Right. Which I then convert as and can describe. I could describe it as pi radians if I wanted to.
Yes.
And this is where the switcheroo is. We're using the word degrees as if they're the same thing, an angle. The angular size of the moon has got nothing to do with the angle to it.
Yep.
And to try and conflate the two is the switcheroo.
It's moronic.
Well, that's polite way of.
Yeah, it's retarded. You got a bunch of retards, booger-eating retards, that don't know what terms mean, and they're convoluting it all in a mishmash, and it comes out with the right answer. That's what's happening here. This is so far gone, folks. They need to be institutionalized from the not actual size degree pixel ratio. This is where it's coming from. Don't forget that. The not actual size pixel degrees ratio from a not actual size measurement.
This then outputs the degrees between the track. So that's this A equals 0.1212. So we do the math.
Okay, so now this, to be fair, we could calculate based on this that ratio. Oh, God knows what that ratio is. These are very strange things. They're projections. But if we did calculate that, yes, we could apply that ratio of the angular sizes of the angular size of the track as a percentage or ratio of the angular size of the moon. Got nothing to do with the angles to it from the observer. Please differentiate the mugging off here.
And people in Discord, you better be on mute. If I have to go back to Discord, I'll mute everyone. You got me, sunshines. Let's continue. Good point, Adam.
I confirmed that myself.
Oh, you did that all by yourself. Oh my God. What did you do? Did you divide one number by the other number? You did that yourself. Now that's validated. You pretender clown fraud of a piece of shit.
0.1212 is the angular size between these two tracks.
No, he's saying it's the angular size. It's the not actual size degree pixel distance in angle in degrees.
See, I'm a generous man, and I would give him, right, based on that listen to the mitigation, based on that composite picture of the two things, if you wanted to describe the distance between the two tracks of the composite picture, and you were going to use a methodology to describe it because you can't measure it in real life because the composite picture doesn't happen in real life. And I allowed you to use the term pixels to describe that distance as a function of the number of pixels that the diameter of that circle on screen has. I would say, okay, you can do that maths and describe that as an angular, and this is where I'm being nice, but comprehend an angular size. It's not an angle still, just an angular size in relation to the predetermined angular size from one view. Yeah, you can allow that, but understand the mitigation that's required to allow it and still comprehend we've not measured an angle yet, as in from the observer.
All right.
That's what that number is. Then they got the distance between them. This is the Google Maps that shows the distance between their two locations, 1.11 kilometers.
So you got 1.11 kilometers of the distance between retards, Astronomy Live and Red's Pretenderic. Everyone following that. And that has to be flat baseline, by the way. But remember, that's a caveat in lieu of all that. We're looking beyond that.
Just a quick question. Do they live, are they like live next door to each other or something? Is that a coincidence, or have they come together to do this?
They came together to do this at 1.1 kilometers apart. Like that is a decent length baseline to measure a non-friggin' angle.
It's not a decent baseline if you're assuming the thing you're going to apply parallax to in your calculations to is 250,000 miles away. The point of convergence is 250. It's a ridiculous number to use, as we'll demonstrate later. That's why I was asking, because if they lived either side of the states, that would be a really decent thing to try and do.
Right.
Because it should it should still have the same blockage, and then you've got a decent baseline to actually have some validity, as we'll show later. But
yeah,
on that point.
So
I think it's.
Go ahead, Brian.
No, you go. I go after.
So what he's doing up here, folks, he took this 1.1212, the number that the ratio. Remember the ratio that he got, right, from the not actual size pixel degrees, and he halved it in 2. Because this isn't an actual right angle triangle. They have their other triangle. Remember, Astronomy Live is over here, right? And Red's Pretenderic is on this side. So what they did, he didn't show it because he's an idiot. What he did was, or what they did was half it. Because in order to do triangulation, you got to find this X distance. That's what they're trying to find. Does everyone follow that? Probably not, but go ahead, Brian, quickly.
Wait, I'll come in a while.
All right. Remember, this X. He's going to get into it. Watch him screw it up.
And then you can create a triangle with that. Now, this isn't the height yet. This is the distance.
So this isn't the height yet. This is the distance
to the ISS.
Yeah, that's the height. That's it. You just contradicted yourself. That's the height. That's X. And he's going to show us this in a few minutes.
Of the midpoint.
I don't think he is.
Yeah, just relax, Brian. He is.
So they cut the triangle in half.
Yep. See, they cut the triangle in half. He's just telling you what I told you before.
0.1212 turns into 0.0606. They know their baseline is 1.11 kilometers. They cut that in half to get 0.555 kilometers. And there's all the numbers that.
Here you go. So this number over here, which is off the screen, right? That's what he just did, and that's X. That's this X right here. Watch what happens below here, right in this vicinity. Watch what happens.
Oh, this is a bit that does my boxing. Right?
Okay, go ahead.
This is numbers, isn't it? So, and as it alluded to earlier, people will want to check, and it's interesting that I can't check, can I?
No,
because the trigonometric function that's being used is hidden, and McToon doesn't state it. I'll leave it at that, because you might think, because at this point this is the bit of trigonometry also that you might start to understand. Because the rest you can't understand because it's not trigonometry. It's been precedent to this. Yeah, it's been, like I said, pressed a bit of ball magic. Yeah, and not even that. It's just complete.
Okay.
I don't know how to describe it other than to reiterate the point that somehow an angular size has been converted into an angle.
Yep. Now, folks.
This is virtual reality that they're displaying.
Oh God. What did you get? Did you get the memo of what I said before?
Yes, I'm just reiterating it. I'm making sure.
All right.
This is D-Rose. Go on. What are you wanting to make sure of? Because that was my request.
It's inaccurate. It's inaccurate. It's not actual. So basically, it's not realistic. It's virtual reality because the way they acquired all of these.
No.
Was from a
no, it's not. No, it's not virtual reality. It's virtual retards.
Okay, thank you.
Okay. What I'm trying to demonstrate is the way in which this angle that's now been derived, which was divided in two, is going to be used. I've got no problem with it. It's going to be used correctly in trigonometry. Okay. My issue is how it's been derived. I'll say it again. We've derived it from an angular size. Okay. It means nothing. When I look at the moon at 10 o'clock or 11 o'clock or 12 o'clock, its angular size is the same. The amount of space it takes up in the sky is the same. Its position and its angle to me, which might be relevant to this picture if you're going to apply geometry, which is what they're about to do, is what would be relevant. The angle to the moon is what I need to take, not its angular size, if I'm going to derive an angle from that measurement. Does that make sense? I can't derive an angle based on a distance in this case. It's a nonsense. This is the switcheroo they've done.
All right. Back to...
Let me just check. D-Rose, does that make sense?
Yes, it does. So, remember what I said before we could... Remember what I said before we continue. See his little X over here? That's the length of the opposite. That is the altitude of the ISS, or the distance to the ISS from this point to this point. That's what they're trying to find. And he's got his little calculations that are sort of cut off over here. Okay? But remember, X. Now watch right beneath here.
Use trigonometry here is what you need to use. That gets the distance to the ISS.
So the distance to the ISS, folks, look at the numbers here. The key number is he just converted it to miles. Don't worry about that one. It's 524.73 kilometers. That's X. That's on this side. Everyone got that?
From their location of 524.73 kilometers.
Not from their location. From this point right here. That's X. Their location's over here, and the other half of the triangle over here. So it's from this point. You screwed that up.
No, that's the distance from the ISS.
Distance from the ISS. No, it's not the distance from the ISS. It's the distance from here along X to the ISS. Clown.
With no no spherical mathematics included.
Oh, God, just shut up. So just remember, folks, what we're looking. Remember I said the 524? That's the X. Watch where the 524 ends up on this booger eater slide.
As far as adding the
after we listen to the fraud
curve between the two people or anything like that.
Correct. There's no curve between the two people involved.
There's no curve between the two people. That means the Earth is flat. Thank you.
This is just the picture.
This is where they want us to go. Okay, so this is where these guys think they're clever, the ballers, and this is why McToon. You'll hear him repeatedly say it, and it's a frustration to Nathan that Jaron doesn't pick it up. But listen, it's his bait. He's baiting him because what he wants to do is show why the chord over 1.1 kilometers, ain't worth worrying about the curvature or the angle difference because you can't measure it.
Yes.
Which is important later. But let me just finish. This is important later in their claim. This bait isn't taken up, but it should be. And yeah, I'll take it up. Oh, you've not calculated that, blah, 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 right? Apply it. Now, like I say, it's important later because this differential they don't want to look at. This margin of error is going to become important later. Because what they're measuring is not measurable, but from this distance. But I think that, like I said, fundamentally, that's bait. Try and get you to go, there's no curve. But realistically, you've not even got a mile. So you've not got even 8 inches of differential to deal with. And you're supposedly talking about something that's hundreds of miles away.
Yeah.
So that differential is I think they're just as bait, if that makes sense.
Yes. It's a train wreck of a disaster of a short baseline. But anyway, it's still, this isn't flat. You still can't get an elevation angle. Brian, quickly.
Yeah, this is the point I made originally. There's a fundamental trick they're doing from the very start, which is they're using a chord line. There's 2 ways to do this using a globe Earth. You either use the equatorial plane at equinox, so there's no tilt, or you use the 2 points on the surface of the globe and you treat those 2 points and all the distance between them as flat. And then you add the R value. What they're doing is they're using a chord. Now people go, what's the difference? There is a difference because they're not going near the R value. They're not doing it. If they did it the way they would be supposed to do it, which is treat the Earth as flat and then add the R value, they would get a completely different value until they add the R. So they're avoiding that point. So I'm hoping nobody can see it. I know you said something similar a second ago, Adam. I know you said that was my point originally. This is what my point was.
To the 10th decimal, you'd have a point in this because this is what I'll come to later. You would have a point. You are correct. We are correct, and that's the bait they want you to go to. But it's to the 10th decimal of a kilometre that the differential is applied at when you're only 1.1 kilometre, or not even that, when you're dealing with a 0.555 kilometre distance. Okay, this is where they want you to go, but fundamentally, I'll give them this. It's not a problem. I won't invoke curvature, even though. And this, listen to how many signs you can have it. It's flat. I'm treating it as flat. He says it with duper's delight in his eyes. Watch him.
Yep. Here we go. Here we go.
Okay.
Yeah, there's more than that going on. One second.
Yeah, the distance they did is 1.1 kilometers. So the chord distance versus the distance, the arc distance is going to be.
Hello. Just wanted to let you know, YouTube has kindly remixed the audio on a different video, and it's been dropped into Discord live chat by Divergent Droid. So if you want to just make a note of what time you're at, and then just start playing the YouTube video rather than the one you're playing, you'll get a better audio out of it.
Where do you put it?
Discord. Anyway, I'll leave that with you. Thank you. Shout out to YouTube. Really appreciate you doing that. It was driving me nuts.
You put it in BALLBUSTERS?
I think it's in BALLBUSTERS text chat.
All right, hold on. Let me get the time.
Yeah, it's at the bottom of the chat.
34:57. 1 second.
Brian, where were you? Phil for us.
Yeah, listen, see this thing about the chord. The reason I'm sticking on that, I understand your point, Adam, that they're using such a small distance that I don't believe they're actually that distance away from each other. I believe they're much further away, but it doesn't matter. They're using that small distance because they want to keep on using chord lines and not doing the way it should be done. The way it's done, right, whether it be 1.11 kilometers or 111 kilometers or 2,000 kilometers, is you treat the Earth as a flat plane, you take your angles, and then you add an R value. And that's what they do. They're skipping over that with this so they can use that chord line for bigger things in the future. So they're always trying to avoid having to add the R value because they know we'll jump on that immediately. But if they're starting off with the R value already added, you know what I mean? They're taking that away.
I don't think it's for the future. I think it's genuinely. I can't speak to motivation, but it just seems a little bit. It's like he's trying to go Jaren there. It just smells like that to me. He keeps saying flat baseline, and like I said, I'm take it, mate, because the chord is. And the other point, the zenith differential is 0.0009 degrees. Again, a non-measurable amount. If you look, when he makes a reference later on in the video, he zooms in on the telescope because he can confirm the angle there, which is relevant to later confusion. But that's not to that measure of... The Vernier's not got that many degrees of points of decimal that you can measure to. So even... And this is why the short baseline makes a mockery of the whole thing, because the accuracy of the equipment isn't able to differentiate the angle you're trying to presuppose.
Yep. All right.
Well, the telescope should be at the equatorial plane, because that's what astronomy do. Equatorial plane. They're either at the equatorial plane or they're treating the Earth as a flat plane that they add the R value to.
Okay.
If they start off with a chord line, just very quickly, if they start off with a chord line, then the R value is already added. That's the point.
The Astronomy Live bit's important because that's the Astronomy Live might use something like this to locate the ISS based on a better way of doing it instead of two blokes down the road from each other. But what they wouldn't do is what we've said earlier. And I want to reiterate that point again. What they would never do, because it's farcical, is to say, this is the angular size of the moon. We'll re-describe it. Make a composite picture of the tracks through perspective, across the moon, 254,500 miles away. Yeah. Put those two composite pictures together. Derive a subsequent angular size based on the angular size of the object 254,500 miles away. Yeah. And from that, equate not a distance, which would be almost pathetically permissible to equate that as a distance, but to equate an angle at the point of interception of the object that creates the transit lines over the object 250,000 miles away.
Yeah.
This is the abomination that needs to be reiterated. This is the mind-boggling nonsense that's been passed over.
Okay. Okay. Can we continue?
I think so. I think I've said it enough. Do you want to do it one more time, or do you want to?
No, don't do it.
Okay, you carry on.
I'm going to go back a few seconds. Get ready, because I don't know how this is going to sound. So let's go back here. Oh, this is a good place to go back to, because remember, if you don't got your Adderall drip out, remember I said that X? Remember that X is 524. That's the opposite. Okay, you're going to see this number show up. I want you to remember where it should show up on the X, because that's what it is, right? Remember that. All right, now listen up, folks.
Anything like that.
Correct. There's no curve between the two people involved. Also, this is just the picture, right? So
it's just a short distance.
There you go. Again.
Yeah, the distance they did.
Stop. Yeah, he's goading him. There's no curve. Why would a baller say that?
Right.
There's no curve between the two. He's just goading him.
Yep.
I mean, I've got to respect. Jaren's not that dumb, right? He's ignoring that because there's a reason. And like I say, they're desperate for that to be one of. When their Wednesday afternoon meeting, that was. Let's keep reiterating that. And so I think respect to Jaren there for not buying or.
Okay. Yes. Yeah. Real respect. Okay. Listen up. YouTube. I'm gonna kill you guys. YouTube. Can you hear that? Okay. Nathan, can you hear McToon? Okay. McBooger Eater. Yeah. Now listen to what I'm going to ask you. Hold up, D-Rose. Listen to what I'm going to ask you. YouTube guys out there, can you hear McBooger Eater? Stop your conversation. Can you hear McBooger Eater? You can't hear him.
Nathan says no.
Unfucking believable.
Did you hear Jaren though, Nathan?
All right, let's go back.
Go back, replay the last little bit, and then I'll look at chat.
They're not even fucking. I'm gonna wring your guys' neck out there in chat. I really am. If I could get out there, there'd be ass whoopings. James Mays, yes, he said yes.
So we can hear it, brilliant. And Nathan, we're already permitting the fact that the sky vacuum thing. We're not allowed to go there.
Thanks.
We've got to just ignore that it's floating in the sky vacuum on the way to an even bigger vacuum.
Appreciate it, James. Appreciate it, James. Cease and desist, Adam. Okay, so we're on this. Let me go. I already got the CC on, so if you can't hear it out there, which I think you can, you'll still be able to hear it. We're going to continue from this point.
It won't change the output much, but certainly anybody that was interested could.
Oh, wait. Stop. That's the wrong one.
There you go.
Stop. Stop.
Oh, there you
Stop.
go.
Stop. It's the wrong one. Let me start it over with the right one because I didn't get rid of the last one. Here we go.
1.1 kilometers. So the chord distance versus the distance, the arc distance is going to be very nominal. It won't change the output much, but certainly anybody that was interested could do a different, right? This
quickly, Adam.
Jaren didn't bite, so he actually divulged his thing because they'd spent so long on it, right? He had to get the sentence out. Oh, the distance, and he uses a NASA word, nominal. That's again a subdivision, but he's divulged it that there is very negligible difference.
Okay,
it's not nominal.
We got it.
Do you see how he had to squirt it out? That's the point I'm making.
Okay,
Jaren
good.
didn't bite, but he still had to squirt.
Good. Yes. Let's continue.
Google Maps uses the Haversine formula, so this is definitely the curve.
We need a Haversine formula to figure out what a curve is, right? McBooger Eater.
That's a falsehood. Google Maps doesn't.
No, it doesn't.
Google Earth does, but when you actually zoom into the map level, it's a flat baseline. There's no Haversine needed. It's a square grid.
Yep.
And so somebody could do a chord distance if they wanted to. So
Okay, we're back to the X. I'm sorry, I don't have it on the screen. Sorry, we're back to the X, folks. This is poor resolution for me, but I'm thinking it might be good resolution for you guys out here. So remember, right before the 20-minute diverging, right? The X. Watch what happens.
It's going to be buried 4 digits deep.
Can you bring back the image of both them crossing the moon for me? I just want to see, did it look like a angular size difference there? Quite a big one from the one on the right versus.
This is a numpty dipshit, appeal because he's lost. Although he is correct. There's an angular size difference because they're using 2 different measuring devices or 2 different cameras. That's why. Okay? We good with that, Jaren?
Versus left?
The angular size of, yes. So this was 2 different cameras.
No.
Okay.
Yeah.
So if one of them is almost half the size of the craft itself, how could you compare pixels and compare distances? I don't understand why the moon.
They're not significantly different in size.
They are significantly different in size, as everyone could see that they are. But this is diverting away from the main point.
It's that one has a different frame rate, and I think that they're closer together. So maybe.
Holy shit!
I did give the premise that you could make this hybrid photo, but again, it shows you're not even comparing apples and apples. If the images have been generated from 2 HyperXG 428.753/2739 PCXs on both sides, then it would have been fine, or 2 P900 would have been fine. But Jaren raises a point there. That's why the shadow is very different, because you're not comparing apples.
Correct.
Yeah. Which is fine. We're hoping to move past this point. We're allowing so much. This is another point of allowance that we'll give them when we say, you can take. Because remember how spastic the term composite photo is.
Yes.
That's a photo from 2 different places, people. Yeah. So I don't need to worry about the 2 different devices, because it's so spastic what I'm allowing right now.
Yes.
A picture from 2 different locations. do geometry on, right? That, you know what? I'll forget. You could have used a Nokia 3810 on both places, and I wouldn't be arguing that point. Yeah, this is the ridiculum I'm arguing.
Yep. We can move on from this. We already know that this is a train wreck. We got it. That it's a composite. We got it. Got it. All right. Good.
Maybe the ones on the left look smaller because of their proximity to each other.
Possibly.
So, but yeah, I mean, you can. We could look at this.
Hold up.
Holy shit.
Back 10 seconds, please. I just want to hear that and then pause.
You want me to go back 10 seconds, then pause?
5 seconds. Just McToon's response to why there are size differences between the two shadows of the ISS. Please.
Yeah, it's moronic. Yeah.
No, I want to hear it again. 5 seconds. Press just the back arrow, not a full.
I already know what to do.
But yeah, you can. We could look at this. I don't think that they're drastically different in size, but it's a good point.
No, and I'm just trying to think if it's that simple, but that's something I'd be willing to do. Is it help us to have a larger baseline? I know we need the ISS to cross the moon for both people.
Yeah, and yeah, as you get farther away, then you're going to get a smaller stripe across the moon, because it'll be closer to the edges of the moon.
Oh, gotcha. Okay.
But yeah, it can increase precision a bit.
Yes, we're going to need a citation for that. I want to see the citation that states what you just said, because you just pulled that out of your ass. Yeah.
You know, the other thing you might have to do, was to take into account curvature.
Yep.
Yeah.
Yep.
Going to use that bigger baseline.
We want to know what size the actual baseline is. We need another ratio from the distance we're trying to see. It is a celestial object in their paradigm. The ISS is a celestial object. It's out there in outer space. It's not natural. I get it. But in their paradigm, it's still a celestial object.
Yeah, but it's not subject to the rules of celestial navigation like the moon is.
Yeah, I understand that. But still, it's on the same principle.
It'd be more akin to a really high lighthouse. So it would be subject to terrestrial navigation via their rules. However, the moon wouldn't. It would still use celestial navigation for the moon.
Yeah.
And that's another one of the mismatches that they're doing here.
Yep.
This is their claim that I'm analysing, not anything else. But fundamentally, that is a really big lighthouse. It's terrestrial. As McToon says at the beginning, I'm going to use trigonometry to derive this height. Well, that's fine, yeah, because that's the emission I want. You are then doing terrestrial navigation, not celestial, on the ISS.
Good.
So
no,
and then
you're
not
reset
taking
the
the
video
distance
by
to the-
refreshing it and then changing the resolution to 720 because it's
can't-
really. You asked me to ask. I just passing on the message.
I can't change the resolution.
It's only in 240. You need to refresh the page, then change the resolution. You only just uploaded it.
3642.
The ISS to cross the moon for both people.
And as you get farther away, then
Go on pause. 3643. Good. That should be good.
You just are taking the fact that you know it's a certain angular size.
yeah, it's 0.52 degrees. Now, yeah, and you can measure it yourself, and Reds makes a point in the video that Astronomy Live shows in a different video.
This is just a stupid diversion. Okay, the not actual size is 0.52 degrees. Who cares?
How to measure the angular size of the moon.
Oh, God.
So there's techniques to do that.
Let's get the white paper on that, McBooger Eater.
You can look it up if somebody didn't trust this number, they could.
What do you mean didn't trust? You fucking clown.
This is brilliant. That's
as well.
brilliant. If you don't trust this number, so off you go to check the number, and it comes back, it's about right. Yeah, size of your thumb. Yeah, that's the moon. Yeah. 0.52 degrees. Yeah. Is that validated what's just been claimed? Does that now mean that the angular size, i.e. the width of your thumb, in the sky, can now be derive an elevation angle, because this is what is being done in the diagram you'll put up, next to derive these heights, heights. He's pulled this, again, angular size, and he's divided it by a pixelation calculation, to give you an angle that you are looking at. It's beyond. Please don't fall for this bullshittery. Do you understand? This is what's being mugged off with people.
You didn't actually change the resolution. You just refreshed it. Can you just click the cog and change it to 720 now? Thanks.
Jesus.
He's going again. He's gone again.
Let's do this. Let's refresh it again. 3710
degrees. Now
let's put a pause on there. Let's go to 3710, 3705. Then we'll go over to the cog so you can watch me. All right, 720. Okay, we good? Here we go.
If somebody didn't trust this number, they can confirm it themselves as well.
Okay.
And like I said, Astronomy Live did that, but didn't want to get into it for this particular.
Okay, we're back to our X. Remember what it should be. You're going to see the numbers come in down here. There they are.
All right, I'm writing that one down. I will check into that and see if I can replicate that.
All right, and all right, let me. There's just a couple more.
You can replicate that. What the hell does that have to do with geometry? Replication or repeatability has to do with natural science and the scientific method, not friggin' geometry. You don't go and measure it again to replicate it. You clown. Sorry about that, folks. I digress, but he's pissing me off over here in the corner.
More. I don't want to get too far into this before.
Well, we already have our clock.
I don't see the timer, so
just take your ass out of here.
It ended, but I'll give you another minute. Go ahead.
I'm almost done. All right. So the distance from there, and it's from the midpoint between them, is 524 kilometers.
So the distance from the midpoint between them is 524 kilometers. That's this line, folks. That's the distance between Red's Pretenderic and Astronomy Live. He just said it. So X has to be this. And he just mentioned that it's this. 524.73. Right? Everyone following that. Watch.
So then you need to get the height of it. So
you need to get the height of it. That's this. X.
This is off of the telescope that Astronomy Live was using. It was at an angle of 53 degrees. So he turned off the tracker,
who gives a shit? Get to the point.
Out as soon as the ISS passed. So it stopped moving the telescope so that he was able to measure this 53 degrees.
Uh-oh! SpaghettiOs! Remember the number I told you to remember that was the X over here on the opposite side of the triangle? It's all of a sudden now showed up on the hypotenuse. How'd that happen, McBooger Eater? These people are clowns, folks. They're clowns. Any comment on that?
Yes, lots. We'll go to page 1. I mentioned earlier why I found it curious I wasn't able to see the trigonometric function that was used. In a lot of cases, you probably ignore it and just trust the integrity of the presenter. I find out why it's important to hide it, because if you did check it, you would see the shittery that's being presented. You can see triangles here, can't you? Yeah, right. Let me describe these triangles to you.
You got a triangle right now.
I just want to describe the triangles they're claiming, because they're not like what's on screen. Okay? And maybe later we'll get into the hybrid triangle that we're about to derive here, but fundamentally I just kind of want to describe the triangle and remember, this triangle is described by the angle that's derived from pixels from an angular size. We've taken it, we've bastardized it, we've turned it from an angular size into an angle, and we've stuck it at the top of, we've stuck it at the intersection point of the two perspectives we've got, and then we've divided it by 2 so that we can use this right-angled triangle to do our calculations from. Like I said, the SOHCAHTOA part was interesting, that in the calculation you couldn't see what was being used. Now, the first point I did was to look at the 962.224, and I hate it when people only use 2 decimal places, especially when you're dealing with numbers like this. It's important to go to 10 until you get to the end. Then you can shrink down. Until then, I think you should use 10. So when I did that, I did see a slight differential between what they're using, which is 0.1212 degree as opposed to 0.1211. Now, if I follow the trigonometry through, the reason I question whether using sine and or tangent is because in a lot of cases that makes a massive difference, doesn't it?
Mm-hmm.
When you're dealing with what this supposed triangle is, which is not measurable, as disclaimed earlier, what I found out the side lengths of the adjacent and hypotenuse were 525.254, so slightly different to them, 524.73, I think they've got, haven't they? And then if you calculate the other side length, the adjacent, i.e. the GP length from the ISS, 525.537, which, if I use the same 3 decimal places of the hypotenuse of 525.254, comes out as 525.254. So I just want to make, this is kilometers, so we're talking very, very small difference between there is no real triangle that the devices could measure here. I don't want to play on, because it's the derivation of that top angle that's really important. Like I said, the point I want to highlight is, I know for me, if I was wanting to highlight one point and make out I was demonstrating something and continue using triangles like this, I wouldn't use the trigonometric function and display it. I'd hope people would move on. If you do display both, which is not what they did, yeah, as QE spotted, there was this switcheroo between the two. Well, there isn't a switcheroo, because they're the same freaking distance to 3 decimal places.
Yes.
Yeah, within a centimetre.
Yes.
Yeah. So to get me, what's being proclaimed here to measure the height of the, can they measure within that distance? No.
Nope.
Right? Now I'll stop there, because, like I said, the next picture is a slightly different thing and a misnomer of what's been presented previously.
Okay.
So then this is the
somebody say something
that I did. How could, if they're only 1.11 kilometers apart, then how could Astronomy Live get a 53-degree angle to the ISS?
This is the point. This is what I'm saying.
His angle would have to be in the it'd have to be in the 80s, high 80s. It could never be 53 degrees.
No, and if you look at Red's Rhetoric's other video where they get different, it's funny, they get different angular sizes and all sorts of stuff. And he's done it previously. This is what they try to do now. So they're now going to try and use the elevation angle of whatever they were looking at. Yeah, the ISS. I assume this is why he uses that. He claims he stops the tracking, of it to define this angle. At this point, he's going to say, yeah, roughly the ISS is at 53 degrees. He's now defining that as an elevation angle.
Yep.
Remember how we got the... So that's the angle ISS to the observer across the baseline, from the observer. Remember how he's defined the other angle, right? 53 plus, what was it? Let me just give it you. 0.0606. So what's 53 plus 0.0606? Do we call it 54 to be generous? Yeah. Right. How many? We know that the other angle on the flat baseline that is derived the 53 from is 90. 90 plus 53 plus 1. Does that equal 180?
Plus 1.
I'm being generous, QE. And if you look at Red's other videos, what happens to that 90-degree GP position of the ISS is it becomes a very obtuse angle. I don't know if McTune would dare cover this. This is where they have to go. So that diagram then becomes perverted. And then you've got this, like, 130, well, make the difference of what you got, 154. So it's ludicrous what they're about to presume, because look at what he's just defined. 53 degrees, that top angle, the downward angle to it is 0.06 and 0.06. Yeah. God, my God, that's ridiculous. Yeah. What does that have to do to the predefined 90-degree angle you derive your elevation angle to the ISS from and is commensurate with the GP of the ISS? Can that remain 90 degrees if 53 and 0.06 are correct?
That's a stupid question.
No, but it deserves
what would it make Red's rhetoric's angle have to be? That's the point. Remember that he's measuring with a P900. Right, so what would his angle have to be if they're only 1.11 kilometers apart?
126 at 90 degrees is that right? I've just done it in my head. 126 degrees, the 90 degrees has to change to, or the angle at the ISS to be 0.06 if the elevation angle is 53. You see where the switcheroos now occurred? Now suddenly it becomes nonsensical because we've derived this angle based on perspective of 2 tracks of a hybrid photograph.
The pixel degrees.
As an overlay on an object, according to them, 250,000 miles away to derive the angle. Calculated not through measuring any angle of interception, which is what they're claiming here between the 2 lines of sight, yeah, but calculated by the number of pixels of a disproportionate overlay, yeah, based upon an angular size and a ratio of that.
Would Red's angle not also have to be 53 because they're cutting it in half? They're making two triangles out of one?
No, because his mate, the other end of the strip, has got 53 degrees. He has to have. Yeah, because the baseline difference is so different. But the trouble is, Red's mate, on the other side, see, because Red has got his 90-degree angle now at 120 odd degrees away from him. His mate, the other side, his angle is 120 degrees away from him. I.e., they're not commensurate. It can't be. The only way is they would have to be on a ball, except, of course, they've took a straight chord. But that ball would probably be the size of what? About 1.1 kilometers diameter.
Well, my prediction of what they did.
Sorry, Bright. James Richards, $2 super chat. Testing. Still working, James. It's still working. I'm on it, baby. I'm on it. Over to you, Brian.
Yeah, I think they took a 1.11 kilometer distance and they both got a 53-degree angle. So what height would that make the ISS?
No. The angle they've taken off the ground is
that's all they could have done.
Right. They haven't taken that angle. Remember the disclaimer for how they obtain the angle. What they've done is this is brilliant. Right. Remember what he said. He zoomed in, didn't he? So he zooms in at the angle on the mount that he's got. So you know, right, and he says he switches the mount off. He switches it off. Brilliant. So at this, we've paused time at this moment, so we know it's going to be the 53 degrees that he's. What is he sighting at this point? The moon. He's sighting the ISS. Yeah. he's claiming based on where the moon is. It could be anywhere in the moon. As you see, he just switches it off when transit time apparently. He's just pulled this number out his arse. What it's got to do with anything, I don't know. Other than it's now an elevation angle that he's going to try and merge, with the angle he's just generated before. Now, as I said, if it had been transit of the ISS would have been, I don't know, 2 hours later, and the moon was higher or lower in the sky, when he switched off his celestial mount that was tracking the moon, what would his elevation angle for the ISS be then? As it transited the moon, the thing you're tracking. Yeah? This is the mismatch in that initial hybrid picture. We've got an ISS and a moon. And he's trying to put these two angles in relation to each other in two different spheres of reference. Yeah, it's a complete misnomer. You can't, like I say, fundamentally, you take the 53, you give him 1 at the top. Look at the triangle he's trying to describe. Does that not tell you he's not using apples and apples to make his triangle anymore?
Yeah, but what Brian's trying to say is if this is astronomy live over here, 1.1 kilometers away, this is not the scale, folks. This would be really tight, right? And the other angle over here to Reds, it'd be pretty darn close to 53 degrees because they're looking at it really, really closely. You know what I'm saying?
It would be, if it was 53 degrees for Reds, it would be 53.009 or is astronomy live. Yeah. 009 of a thing that, as I said earlier, if you look at the dial on his telescope, it doesn't. The vernier doesn't go to 0.009.
Right.
It's 53 point something. Yeah.
Right.
Point to 1 decimal. He can't measure the differential between the two sites that you're referencing to make that difference, to have any validity to it. Both those guys, see, and this is why he's only shown one side, because the other guy hasn't got a mount, has he? He's just taken it and again assumed it'll be symmetry the other side.
There it goes, right there, Adam. I put it up on screen for you.
So 53 point whatever, you know what I mean? And that's 53. So yeah, but that's the point. Look at the measure of accuracy. Now, what was the angle that at the top? 0.06. Oh, we needed another gradient scale underneath the one you've got, don't we, to go to the secondary decimal point that's being described of the angle that we're measuring.
Can I just? I don't want to cut you off, but I just want to make the point I'm trying to make clear. For one person to have a 53-degree angle, and for that to be only halfway, that's only 0.555 kilometers to someone that's 1.11 kilometers away, and they're taking an angle, and that will make their angle basically equal, right? Now that's over a horizontal plane. If you make that into a chord length, and you give the two of them two tangent planes, right, then that shortens their angle again.
Yeah, to 53.008 instead of
No, it won't be. It won't be if they're using tangent planes. It's going to shorten their angle again once they do you understand what I mean?
No, I'm disagreeing with it. I'm saying this is what
because when they just 1 second.
You want to hear the
just give me a second.
Why? Okay.
Well, I don't know if you understand what I'm saying yet.
I just did. I don't think you've heard the rebuttal, but make it again.
Go on then.
I'll check. No, I'll make it again. I'll double check. I'm not misunderstanding.
The point I'm making is they're 53 degrees from each side. They're claiming a chord length, right? That they're taking a chord length, right? That's a 53 degrees from a chord length. It's not from the surface of their globe. So if they both have to have 53 degrees, when they add in that arc, then and they use two tangent planes, then that makes their angles even more shallow. Because it won't even be 53 degrees because the chord length is underneath the arc.
Yeah, so that is the point. So yeah, if I was to be accurate, generate it as a chord, I mean, the graphics wouldn't be able to demonstrate the arc that the ball would have in terms of the picture we've got. But the difference in the angles is one person would be 53, and one person would be 53.009 degrees if you were going to take that into account as tangents, two separate tangents at where the two guys are. That would be the differential. So I'm saying this is what McToon wants you to argue. 53 or 53.009.
All right, can we continue?
No, does that make sense, Bri? See that I understand. Is that the differential you're describing, or?
Well, no, I'm talking about they must use, because they've admitted they're using a chord, which means they're using a horizontal. Now that 53 degrees that they're taking it from that chord line. So when they then translate
they're
that,
not taking it from they're not taking it from the.
But that's what they're claiming.
No, they're not. They're still taking it from a tangent. They're saying the disclaimer at the beginning was we're treating it just as a straight line, as if that section is virtually flat. And even if you do, like I said, the differential makes such a small difference that you're arguing over the second or third decimal place. In this point, it is valid over distances, and this is why I said it's interesting that they picked such a short distance, and because that differential is kind of outside of the accuracy of any of the instrumentation you're going to use.
Yes.
But the 53 degrees is such a shallow degree for between 1.11 kilometers between them. For both of them, that 53 degrees. That would make, over a horizontal plane, that would make the ISS they're trying to measure to a lot closer to the surface. Go on, I'm not going to continue on with it.
If I create two tangent points instead of a chord, so instead of 53 and 53.009, to extend them out slightly, it becomes 53 and 53.011. Does that help us? Is that still within the tolerance of any of the equipment that's been used to make these observations?
No, it's not.
Point.
But
yeah.
What they actually did is they took a 1.11 horizontal plane, 1.11 kilometer horizontal plane, and they claimed to get 53 degrees each, or around that each. And then they tried to turn that horizontal plane into a chord line and add in the arc over it. This is what they're at. I don't see how you can get 53 degrees to something when you're only halfway to someone that's 1.11 kilometers away from you, and that thing is supposed to be 500 kilometers up in the sky. You would have to have in the high 80 degrees. There's just no way. My point is that it's everything they're doing is screwed up. Can't do that.
Right. Well, it's screwed up.
You understand that the person isn't the other side. So if you look at this triangle, and what you've got is 53 degrees for reds, and then 1.1 kilometers either to the left or the right of that baseline is his mate. What's his astronomy live? So he's just in front of him. No, he's just behind him. It's easier for me and my maths. Yeah. So reds is is whatever distance he is, because he isn't a distance, because we're measuring a terrestrial object in the sky. So we can't say where the GP is, can we? But we can say we've got an elevation angle to it. Yeah, we could give them that if they did measure that, but they didn't. They just lined it up with the moon and gave an approximation based on that. But if we take that 53, that's reds. Now his mate, he's 1.1 kilometers on the same straight road behind him. So his angle will be 53.009 degrees. So in regards to the instrument, it will demonstrate the same value, because the instrument can't go to the number of degrees that should be commensurate with it, because it's such a short distance.
All right, we good? Can we move on? Yes.
I hope so. No, that's a good point because if
move
you
on, I'm not happy with it. Move on.
If you try to think of it,
oh brother,
but this is the way they've described it, John. Yeah, and this is another. Yeah, what he's done is split that triangle in half.
I know what he did.
Not what his mate's on the other side. On the first bit, he's got his mate on one side, looking up at the moon. Right, that's not what this diagram shows. The two perspectives, the two eyes. Reds and Astronomy Live are literally next to each other in this diagram. Yeah, but I don't think that's been understood because people are assuming that there's a 5.5 meter baseline between the eye and the ISS, and then on the other side there's another eye. I want that. Yeah, that's not what this diagram's representing.
Right.
This is just taking one eye and an elevation angle, and if you want the other eye, it's 53.009 degrees, literally virtually lined up.
All right.
Yeah.
Good. You good?
I'm good.
Using a flat baseline here. Now he does also do it with a curved baseline, and so
so he's going to do an angle with a curved baseline. That's geometrically unsound. You would fail. You, Astronomy Live, and Red's Pretenderic would fail Intro to Geometry 3rd grade. Right now. That's a nonsense. You're dividing by 0. Essentially, that's what this is. What you just said. You're a retard.
You can do it with both of them, and it's going to make.
No, you can't. You're a retard.
A difference of a.
There's not going to be any difference. You can't do it.
3-4 digits deep.
Yeah, 3-4 digits deep. You're 3 to 4 digits deep into your IQ. 0.00148
in the calculation, but you certainly can compare the two to see.
No, you can't. It's a nonsense.
If it makes a difference, that matters.
But he doesn't know that. That's why you're telling him that. He's clueless.
I've looked at it. It does not.
You've looked at it. You haven't looked at shit. Your slobber nurses couldn't resolve this.
But I don't have those numbers in here.
Yeah, you bet you don't have those numbers.
So we have the distance to it. We have the angle.
No, we don't. No, we do not, sir. You conjured a distance from a layered cake fallacy fiasco of superposition over superposition of superimposition on not actual size degrees pixels. That's what you've done here. This is a clusterfuck of epic proportions.
Angle to it, and so this is just, again, trigonometry. So
this isn't trigonometry, folks. This is as far away from trigonometry as you can get.
This gives you the altitude when you take the 524 kilometers.
Well, I thought the altitude was over here on the X line before. Right? Why is it over here? On the hypotenuse, when you said X on the previous slide. You don't know what you're parroting.
Times the sine of 53 degrees.
Bullshit.
Solve for the opposite side there.
Solve for the opposite side. Why'd you have to solve for the opposite side? You already did it. Remember on the slide before where I showed the big fucking X?
And that gives 419 kilometers.
Just pause there. That's interesting, isn't it? It'll come to that. But there's a super chat. I have been a little remiss. Also, James Richard, thanks again. It's a good job they're not lost at sea. I agree, James.
Thanks, James.
Remember, guys, we already calculated and demonstrated when they hid the trigonometric functions. So,
yes,
thank God they did. We've already made the point that we know the height. You see, we know it. It's the same to 2 decimal places as the hypotenuse, isn't it?
Yeah.
It's 524.74. Yeah. Remember what's being these triangles, mate. You claim basically, as Brian was saying, you've got 2 guys looking up at the sky, conjuring an imaginary angle from composite overlay derived as a ratio from pixel to pixels of the shadow overlay of an object supposedly 450 miles away as it overlays on an object 250,000 miles away. They calculate that angle as a percentage of pixels, not of a previous angle, but of a previous angular size. That's how we get to the triangle presented.
They're degree pixels.
Degree pixels, yeah.
Yeah, they're degree pixels from a not actual size.
high. So this did not use anything from.
This did not use anything. What the hell does that mean? This did not use anything.
Trusted from somebody.
Where's the CC at? Why isn't it giving me CC options? Jesus. So I'm going to do 5 seconds. Listen to this sentence.
Not use anything from.
Let's do 5 seconds more. Listen to it.
18 kilometers high. So this did not use anything from.
This did not use anything from. You are a retard.
Trusted from somebody. This was.
What do you mean trusted from somebody? You screwed the pooch on it. Well, you didn't. You're just mindlessly reporting on it. Red's Pretenderic and Astronomy Live. You are geometrically illiterate. You're clowns, essentially. And you're just reporting on it. You don't catch it because you're just as much of a clown as they are.
It's confirmed personally. The side.
Confirmed personally? Confirmed by what? This train wreck of an epic dumpster fire. You freaking clowns.
This is the moon in angular size was the only.
Yeah, the not actual size was the only thing they used. And your not actual size degree pixels. That's what you used. It's just unbelievable. I'll tell you what there, Booger Eater. Why don't you do another track of the ISS yourself and have the moon closer to the horizon? And then let's see those elevation angles off a curved adjacent. Let's do that. Let's see what its altitude is then. That's going to show you that this is a giant carnival tent clown show charade. That's what it's going to show.
Thing related to the size of the moon used, and of course, that can be done yourself as well.
Yeah, with your thumb. Thanks a lot.
So there you go.
There you go, Booger Eater. We're done. He isn't going to say anything. He's going to divert away to another topic. Everyone got that? We good? Any final thoughts?
Yeah. I've been quiet for a minute because I was just looking at that picture. And that's a claim in that picture that I had an issue with the previous claim because we as we demonstrated the opposite in the hypotenuse, or in the previous diagram, the adjacent and the hypotenuse were within 3 decimal places of each other. So described as the same. If I now look at this triangle that's being described here, I've got a problem, haven't I? Because
yeah.
Because if I just take, I've not done, because in the previous triangulation, the GP was presumed to be 0.555. Remember, half of the 1.1 kilometers.
Yeah.
If I just take the height, and I'll do the adjacent length, i.e., the new distance to the GP of the ISS, based on these angles in a second. But if I just take the height, so the sine of 53 is equal to the opposite over 524.74, which works out to be, I haven't pressed it yet. Oh, that's not good. 75174. So when previously to 2 decimal places it was the same, 524.74. If I apply that to this triangle that's demonstrated here, the height comes out to be 419.059975174. So 419.1, which is not the same for 2 decimal places as 524.74. Suddenly we're making a whole new claim that's nonsensical with the previous claim, supported by the previous claim, apparently.
Yep.
I'm going to go and work out the distance to the GP that is no longer 0.555 kilometers. Give me a minute.
Take over for a second, Adam. I'll be right back.
I'm working out the base length.
I know you are. Just take over anyway. Take over in silence. I'll be right back.
Good, but I'm not.
Or Brian, you could fill in.
Brian, do you understand what I just said there? Right, yeah. So from the previous triangles that they've used, which has got the observers and that, we've now gone to this triangle, yeah, and we've got a 53-degree elevation angle. Based on that side length that was derived from the other triangle, which is from the ISS to them, because they derive the top angle based on that previous description, which I won't do again.
Are you doing a depression angle from the ISS? Because I can't see what you're doing. You're talking about a depression
so
angle.
they've derived that via the track paths, and they're trying to use geometry and commensurate angles. So as the points of intercept, that's the angle they've tried to describe describe that. Now they're trying to say that that is 53 degrees from the observer. It just seems nonsensical the way they're trying to put this together to me. As I say, all of these numbers are derived from. This is derived fundamentally from angular size. How do you get an angle from something that's actually defined as an angular size? There is no angle.
This is probably a bit non sequitur, but or might make not enough sense. But if the ISS was 40 meters wide, let's just say, right, an angle of 53 degrees to it would make it 40.114 in size or in distance. So
they've not mentioned the angular size of the ISS. The only time they've done is in mitigation, when the angular size was different from the two devices when they produced the overlay, which is what Jaron spotted. The shadows that you've stuck on, overlay there. Well, look, they're different angular sizes for your ISS, which, as we can say, is not really due to the different distances because they're only 1.1 kilometers apart. It just shows, like I say, going back to the level of the equipment, it's beyond a joke. How do you then derive anything from two things that aren't the same?
Well, they're trying to find the opposite of a triangle. They are giving us an adjacent length, right? But they're not giving us an adjacent length because they're going to claim to be using a chord, which will be less than 1.11 of an arc, right? Slightly, right? It'll be a small difference, right? But even if we use the 1.11 as the adjacent length, they're giving us a 53 degree angle. Now, what does that make the opposite in height? If we make the 1.11 kilometers the adjacent, then what does that make in height the opposite?
In the third point, right, they define the height. Yeah, they define it as we said. It's the same as the height. It's the same as the hypotenuse to 2 decimal places. Why, after they've done that, are they then going to go to this diagram? These numbers in, which is going to give them a different number. Why? When they already had it from the previous geometry. That's my question. Why are we've already ascertained it. And now we're moving to a singular perspective, applying the elevation angle. Yeah, and using a side length based on, and this is based on the differential, based on binocular vision, fundamentally, isn't it? Because you've got two people 1.1 kilometer apart, so you're doing all your maths based on that to get a side length, which is so without any validation, that side length. Now, what you do with that side length, the only thing I can see that's valid is the elevation angle. And even that's dubious because as it's presupposed, it's not an elevation angle to the ISS, it's an elevation angle to the moon when he thinks the ISS is about to arrive and he stops it there so that the transit can occur. So there seems to be no validity to even any of the derived data that's in there. It's outside of the purview of the accuracy of the equipment, and it's applied wholly incorrectly. I say, and fundamentally, I'll say it again, make a derivation from angular size to give you an angle, a crossover of perception. Yeah, it's just corrupt. And what they're purporting, that's the thing that needs to be just stayed on. Where did they get that angle, that top angle, to get the side length that we're looking at now? To get it by telling you that the angular size of the moon, yeah, if you overlay tracks and and calculate a pixel percentage for the tracks to the angular size of the moon, that will give you a angle commensurate with the point of interception of the two observers 1.1 kilometers apart. That's where they derive the angle they work everything from. That's the switcheroo. Don't look at the rest. Look at that first bit.
Well,
it's perverse, right? And if you work with anything else, you're being mugged off. Because if you don't look at the point that you've accepted an angle derived from the angular size of the moon, you've accepted an elevation angle, yeah, based on the angular size of the moon, you're getting mugged off, aren't you? Wherever you go and critique, and it's been fun, but fundamentally that's the point that needs kind of jumping on.
Well, if I just use the distance to what's claiming to be the sub point of the ISS of 0.555 kilometers, and I use a 53-degree angle, that makes the height or the size. Let's say if you were the angular height from the surface up to it to be 0.553 kilometers. Do you understand what I mean? If I'm to use what they are giving, then that makes the ISS just over half a kilometer high off the surface. 500 meters. If I use what they're given, which is a 0.555 kilometer distance and a 53-degree angle, it makes the ISS 0.55343 kilometers. Do you understand what I'm saying? I don't know if you're hearing me.
No, in the first triangle, it makes it 524.74 on the first one they claim. In the second triangle, it makes it 419.0759 height.
Not if you're looking for the angular. If you're looking for the size from the surface up to the ISS, based on what they're giving, it's just over half a kilometer.
I'm looking at their triangles and their claims. I've just worked out.
Yeah, but the point I'm making is if I use what their numbers, which is a 53-degree angle and a 0.555 kilometer distance, then that makes the opposite side 0.553 kilometers. A height of half a kilometer.
You're reversing the parody I just made, yeah. So in terms of the height.
Yeah, if I was going to argue it, that's exactly what I do. Is but not that I even get into that far. But I'm just saying it makes their claim. It's basically they're claiming. Both of them are claiming the ISS is half a kilometer high off the surface of the Earth.
If you go to the second triangle,
because they're using triangles. They're using right-angle triangles. So let's use them.
which by definition has already denied the first triangle they used to get the matching hypotenuse. Remember, there's the transference of the hypotenuse here. In the first triangle, where the hypotenuse is within 2 decimal places to the adjacent, and then transfer that hypotenuse, calculate a new height. Yeah, this is the mugging off. They're just pure delusion. It's just pure sleight of hand. You're moving from things that are not commensurate with each other. So again, you're dealing with apples and oranges. You're not moving from one apple to the next. And people are biting on the next apple, thinking it's an apple. It's an orange, mate. Yeah, don't bite on it. Look at what's happened. the layers in this is really quite cool. Got the mugging off of accepting angles from angular size. You got the first triangle created where you already know the height, and it's within 2 decimal places of the hypotenuse. And then we move to the observer to calculate a new height, which is 100 kilometers different or something like that. The old height that you calculated it from, based.
I think that. I'm not arguing with your maths because you obviously know what you're talking about.
I'm not arguing the maths. The maths is what it is.
If I was going to go at that, I take the fact they're using a triangle they're cutting in half, which is 2 right-angle triangles. Both those right-angle triangles have 0.555 kilometer length, 53-degree angle for each person. That makes their ISS just over half kilometer high. That's exactly where I go to. Because if you start, I understand what you're doing. You're back working the nonsense they're doing, starting with an angular size of the moon. Whereas I just ignore all that and go straight to, so you're claiming it's half a kilometer high. Because basically, if I use right-angle triangles, which is what they're using, it will be half a kilometer high. If you understand what I mean. If you look, all their BS. Sorry?
Yeah, but to use that rebuttal, do you understand how much stuff they've got you to swallow? They've got you to swallow the adaptation of an angular size to be able to convert it based on pixels into an angle, right? From then to take that angle that derives the hypotenuse, which is within 2 decimal places of the adjacent, so you've already got the height, then transpose that hypotenuse onto a new triangle to give you a difference of, and this is where what we're arguing over, whichever way you want to work it now. Now, based on which side length you want to calculate, you'll either get a height of 0.05 or 400 kilometers, or the converse. So a height of 0.5 and probably a distance of around about 400 kilometers. This is the final point. You've accepted the mugging off twice. You've been mugged off twice. Right? Do you get me? To make that critique, you've got to spot the 2 bits before it, allow you to finally get to that. Pick the 2 bits up before, not that. Yeah, because critique that triangle is to swallow what they've given you.
But the bit I'm working off of is that they, first of all, can't be using a curved surface because they're having to use 2 right-angle triangles that are both 0.555 kilometers long. So they must be using a horizontal baseline, so it can't be a chord length, number 1. Number 2 is if I use triangles and look past all the other nonsense they're claiming.
We've already addressed that point, and the ballers will address that point with 1.1 kilometers apart. Neither devices accurately measure to the 3 decimal places. They measure to 1. The differential in the angles will be 2 3 decimal places, and therefore they can negate that and call it a flat plane. That's why we allowed them to have it. So it's not a point of discussion. They can have it. We don't need it because that's what McToon was trying to get people to bite on. Yeah, he wants you to argue that because ultimately you're arguing for nothing. You're arguing for what? 2 centimeters, 3 centimeters over that distance.
I'm not arguing the point that. The point I'm making is I'm not arguing with him about that. The point I'm making is we're treating it as flat then. Hang on, we're treating it as flat then. That's my point. We're treating it as flat then. And if we're treating it as flat and we're using right-angle triangles, that makes your claim to be that there's a thing called an ISS that's half a kilometer above the surface. That's where I would go with it. Now, maybe I'm wrong mathematically to go there, but that's where I would go with it.
You are. That's just why I'm pointing out the other things before.
Well, look, if I was going to be involved in that, I wouldn't have even gotten that far. He'd be back, right? Because this is my point. He'd be back when he said the angular size of the moon. He'd be back sweating it out, trying to come up with somehow that perspective is added into the apparent rise and fall rate of drop and rise rate of Polaris, things like that. That's what he wouldn't get past that point with me. So I wouldn't have to worry about getting here because I wouldn't be here. I'd be picking on other things altogether before we'd ever get there. And I'd be critiquing what they're doing, showing me that in astronomy, blah, blah, blah.
Brian, the point of tonight wasn't to do that. It was to demonstrate how they're trying to mug people off and deceive them. So in the process, that's what I've been trying to describe not how I could take that argument apart. I don't need to, because it can't go past that initial point of angle conversion. But the reason we followed through is to show how misdirection is occurring here. And hopefully people have gathered that misdirection, yeah? First point, the second point, to get to the third point that some people will argue, and the mismatch, yeah? I'm not really bothered about the maths is good because it highlights how they're the misdirection, that they're not the same triangles, even though they should be the same. They've got the same hypotenuse from the same, yeah? This is what they're doing. And that to me is the important point, that people can see through the rhetoric, thank you, Reds, yeah, that's being portrayed here, and how the presentation can mislead you, yeah, or not even just deceive you, because that's the purpose of this of Reds and what McToon's done, is to deceive people into what's happening, yeah, and hopefully we've demonstrated that.
Yeah, look, I'm not going to argue with you about it. You know those maths better than I do. You obviously have to working it out in a way. Obviously, I haven't done that. Now, I understand that you're using. I understand the processes you used, but I can't argue about it right now. I'd have to have it right in front of me and go through it. As I said, I wouldn't have even gotten to that point in an argument about it. But I understand what you're doing. I have to pop out. I'll try and come back in a minute.
So just highlighting the deception, that's what I want people to get, yeah?
Oh, they got it.
The second point, which is QE's point, is look, do you think that... Are you back, by the way?
Yeah, I'm back.
Oh, yeah. All right. So I need to... Do you think... Because I need a glass of wine. Do you think that McToon understood any of that?
No, no, obviously not. You could hear him talking in between. It was gibberish. Nonsense, contradictory horseshit. He was talking about absolutely nothing. I would have stopped the whole thing. As soon as you got angular size, you're going off of angular size, trying to get an angle from not actual size pixel degrees, your ass would have been grass. I'd have just tore you up there. That's where I would have stopped it. So, yeah. This was a good one. Oh, he went and got some wine. When he comes back, I'm going to give him a math problem. Yeah, we got some. Go ahead, D-Rose. We're done now.
I was going to say, it was very good, and I tried to stay as quiet as possible because I really wanted to learn. And I just enjoyed it. I enjoyed every time I observe. I get to witness and see how this whole thing is unpeeled, and you can just see the rot.
Oh, yeah.
The rot in the middle. I love it, man.
Yeah, because it's rotted at the roots. It's rotted right when they started with angular size. It rots from there. Because it's not actual size. Now, the other rotting part, when they put the two different tracks up, and the distance, they took the ratio of the distance of the angular of not actual size pixel degrees. This is a farce. Somebody said farcical during the presentation. It's exactly what this is. This is a farce. This is a Tootsie Roll dick adulteration of simple geometry. That's what it is.
Tootsie Roll dick.
Yeah, Tootsie Roll dick adulteration. That's what it is, isn't it, Adam?
Oh, yeah. Oh, no, yeah. There's many adjectives to go with.
Hey, give them credit for resilience and relentless stupidity.
Yeah,
at least they're consistent.
Yeah, I'll give them credit for that. Listen, so I didn't see the other angle. We only seen the angle that I know we're going deep into this horse shit, Adam. Just humor me. Because I don't think they know what triangulation is. A lot of people don't. So I need that other angle. Did Reds get another angle? Did he measure an elevation angle? I just want one triangle, right? I want one triangle with the degrees, the alpha angle and the beta angle. You follow that? Oh, Adam.
No. The only angle he's got is when he stopped his
Let me see if I can't put something. Okay, go ahead, Adam. Speaking, I'm going to go find something.
The only angle he's got is the 53 degrees he sighted whilst observing the transit. But it's that 50 degrees that's relevant to the moon. So I'd ask if following week or day the moon was at 42 degrees, how that would affect his calculations. It's not the ISS we're measuring, is it? Somehow it's the ISS we're measuring, gain the hypotenuse, which is the same as the height, then take that height and apply it trigonometrically to the elevation angle applied to the moon, the 53 degrees. There's a new height that's 20% different as opposed to within 2 decimal places to the previous height that we calculated on the hypotenuse. I say it's deception here. It's sleight of hand. Yeah. The first and most fundamental point being we take angular size, divide it by a pixel ratio, by a composite photo from 2 different devices that are at 2 different focal lengths.
Yes.
Okay. And then from that pixel ratio, divide the angular size by the pixel ratio, or multiply by the ratio, to give us an angle of interception, to then do trigonometry on to calculate a hypotenuse, which we can also calculate the height, and they did. So they tried to hide that. And then from that, use that hypotenuse in a completely different triangle to calculate a different height.
Yep.
20% out, even though we just defined and shown that using the previous trigonometry, which we gained the hypotenuse from, we used the same trigonometry to get the height, and it was exactly the same within 2 decimal places, which made sense when the people were 1.1 kilometers apart. There's not going to be that big a differential, and there shouldn't be. But then we take that figure and apply it to a different triangle to give us a different height. One of those triangles doesn't make sense. One of them's a sham. Yeah?
Yes.
More fundamentally, the angle at the top of those triangles is the biggest sham. It's derived by division of a pixel ratio based of a composite photo. It's the biggest cluster screw of nonsense to derive a number I've heard in a long time. As I was saying to Brian, if you accept it from that point, if you take that, what was it? 962 over 222, or to give you a ratio of 4.29, you move past that point, you're screwed. Because actually there's some nice trig in there otherwise.
Otherwise. Oh my God. Now, what was I going to do? I can't find anything. Hold on a second. What was I going to do with triangulation? Can't find any good stuff on here, which is surprising. Well, it shouldn't be a surprise. 1 second.
Anyone on the panel comments? Because I've waffled enough.
I believe what they did by their broad audience, which are a bunch of, common newbies and normies. I think they can't, discern it like this. So I think they're going to use this. They're going to be on TikTok and other platforms talking about, yeah, see, this proves that the ISS is really way up there in outer space. And they're probably passing by the moon, literally. Watch this. They're going to be passing their video around. There's some big booger eater video. Adding more poison to the well.
Let's see. Let's see if I can do this for you, Adam. 1 second. You still there, Adam?
Yeah, what you got?
What? I got to share it so you can see it. One second. Let me go back here and whack. 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 Go live. All right, there we go.
Okay.
1 second. That's not what I wanted. You can see it. No one else can. All right, now we can see it. So do you see the triangle here?
Yeah, you're gonna need law of signs there.
Yeah, you damn Skippy I am. You see this? Okay. So that's what I was gonna say. We can use the law of signs to figure out these sides, can't we? Because that's what they did, those crayon munching. Well, that's what they should have done. The crayon munching idiots. So what you do in triangulation, you could do it this way, right? Using the law of signs and figure out B and A. You should already know C, but you can also figure it out too, right? So what they do in triangulation, they want to know this point, how far is this point away from this baseline, right? So you make 2 right-angled triangles, and then you find the opposite side to get the distance to this guy. So I need that other angle because we already had the angle that Astronomy Live got, right, Adam? Yeah, it's over. Look at you.
Yeah. Again, you see, it's where that angle's coming from. I looked at that angle, right, and I've tried to mitigate what they were doing, right? So we've got this crossover point at best, and that would be assuming that the angular size pixel ratio for the transit shadow was commensurate with the angular size of the moon that's 250,000 miles behind it. But if he did do that, in the transit ratio, you could measure that pixel differential and approximate it into what it is. What you're doing there is you're putting a scale to something, aren't you? So the scale you're going to use is your pre-assumption of the diameter or the radius of the moon. Put your scalar function onto it. If I did that, then I could at least calculate, because what we've got is and even though the way McTune shows it is he's got a big triangle and a small triangle on the moon, but it's obviously the opposite way around. You've got 1.1 width at the bottom, 400 miles above the intersection point, and then 250,000 miles away, your triangle. Big. So you've got a huge triangle on the top and a little one on the bottom, which is, I say, the opposite of what they describe. But if you did do that, then at least you would have amount of shadow distance that you could apply a scalar to based on the R value of the moon.
Right.
Even then, at best, you'd have that. Do anything, even with the angles you've got, you would either have to know the distance. The
distance from the ISS to the moon, right?
Yeah. And then you could work from there and calculate the angles based on that. But what you can't do is take an angle and apply it to the triangles. At best, you could take a side length from
right. I'm tracking.
Yeah?
Sorry, I got stupefied by the McBooger eaters. You're right. You can't do anything with the triangle that I put up on there. You can't do it because you need. It's a. Oh God, is this frustrating going through this?
The fundamental description of what you're looking at is an angular size.
Yeah.
An angular size needs a scalar applying to it.
Yes.
That's what I'm saying. That the only scale you could use is the radius value of the moon.
Yes.
Right, which is what they kind of do, but then don't use it as a distance, which is what it is. It's like this much of a scale I don't know. Right? So you define the scale and then you've got that distance. But what they do is then go, no, it's an angle.
Yes.
And they turn it into an angle, which is the only relation it had to an angle was its angular size. It was never an angle per se.
Right.
Yeah.
Yeah, it's just angular size. That's where it all crashed and burned. Right there. As soon as he said angular size, it was over.
Yeah.
Yep.
There's a logic, and when they overlay the picture, and you think, okay, well, you could do that, couldn't you? at that point, what are you describing that's happening? And like I say, you're describing an angular size of the overlay of the shadows, and that distance is created by the distance of the two observers, the point of crossover, the ISS, and how far away the moon is.
Yep.
Yeah. But to apply a scalar to it, you can do one or two things. You can presuppose the moon, which is useful, but then the only other thing you could do is presuppose the distance to the moon, and therefore you've already presupposed the distance to the ISS.
To the ISS, yeah. It's a circle jerk.
Yeah, exactly.
Yeah. Yeah. This was a lot of fun. Sorry, I was getting frustrated in the beginning. Where'd Nathan go? I liked him popping in and out.
He was just on production values.
Yeah, that's right. Yeah. Too funny, man. This is a good one, but we're going to be introduced to the new hotness because we have Red's Pretenderic and Astronomy Live. Boy, I'd like to run into him in a dark alley. But I digress. And Astronomy Live recently, because it's the new hotness, get the distance of the sun. Using some bullshit. I just flipped through it a few days ago, and I think Nathan, I wasn't, because we're supposed to review it on Nathan, so if it doesn't happen by next Tuesday, guess what?
We're doing it next week?
Yeah, we'll be doing it next Tuesday. I'll put the natural science and the scientific method on the back burner for the week after that, and we're going to go through that. So, have you watched it?
I've seen bits. That's the one that's, when Brian was talking, he's back, and when Brian was talking about angles, and I was saying it's only 0.009 of that 1.1. This, they use a really decent distance, so you are going to have to now, you're not going to put a pre-assumption of a ball in an angular change, and you're going to adjust the elevation angle you measure and tweak it based on R.
Yes.
So you're going to change your angle measured from reality to comport with the ball for it to make sense. This is what they do in this next bit.
Yeah.
You have to.
It's going to be.
Can I ask a quick question? Sorry.
It's going to be about as big as a belly laugher. I don't think you can get anywhere close to this belly laugher. But like I said, I haven't reviewed the other one. I can just guess that I don't. Do you think it's going to surpass this one in abject retardedness?
Absolutely.
Is it? Brian's are absolutely. So they're going to get more retarded than not actual size degree pixels.
It's that headline of this one.
Brian says yes.
Yes, because
claim,
the reason I say that, the reason I say that is because they so eloquently prove that it's definitely a horizontal plane, a stationary horizontal plane.
Yeah, but that's not dumber than the non-actual size degree pixels. That's not dumb. That's just revealing the underlying truth.
Yeah, it is the way they do it. Well, we'll leave the audience decide. Right? We leave it up to the audience, I suppose.
Okay, fair enough.
Brian.
Can I ask a question? Sorry, go on, Adam.
The question for you, is this reasonable? We're going to take 2 pictures of the moon with the transit of the ISS, and then going to overlay them, measure the distance between the 2 overlays, right? Calculate that distance in pixels, divide by the number of pixels that the moon takes up, right? This is what, whatever that number is, Shazam, I'm going to then use that number, that angular size number. I'm going to divide it by, I'm going to use that number to derive a ratio based on the angular size of the moon from one of the cameras, then take that number and mean that it means the angle at the top of a triangle.
You ain't getting dumber than that, Brian. I can't see it.
Well, this is what I was going to ask. Remember that 53 degrees? That's definitely an elevation angle, not an azimuth.
That's fine. That's from reality.
No, we answer the question a second. That's definitely a 53 degree elevation and not an azimuth angle.
Correct.
Yeah, right. So that means, this is why I came back in, that means, because Toon was very specific at the start of that they're using trigonometry, which means they can't be using curved lines. I don't care what the small differential is in the distance.
Right.
I don't care. Right. I don't care if there's a tiny amount of arc within their belief. It means nothing. They claim they're using trigonometry. We were very specific about that, and they said it more than once.
Yes, he did.
Yeah.
Yep.
So that means that they measured a half a kilometer height to the ISS. The ISS has to be half a kilometer high. If they're 0.555 kilometers from the sub point of the ISS, and there's a 53 degree angle each, they measured half a kilometer high, because that makes the ISS 0.553.
No, that needs qualifying. So, yes, it makes the ISS 0.55 high or 419 high based on triangle number 3. However, if you take the same hypotenuse value used in triangle 3 as you use in triangle 2, which is 52474, then the height would also be 524.74. So we've now got 3 values for the height based on their triangles: 5274.74, 419.0759, or 0.55. You can take your pick, Brian.
Yes, but my point being is that they were very specific. They're using trigonometry, which means not curved lines. And if we take their exact numbers of the length of the adjacent, and we take an elevation of 53 degrees, that gives them a height of 0.553 kilometers. That's just over 553 meters above the surface. So no matter what else they're trying to bring into it, if they're using trigonometry, which they were very specific about doing, then they measured half a kilometer height, just over half a kilometer height to the ISS. There's no way around it for them.
Yeah, do you see what he's saying? You follow what he's saying. They're not doing triangulation then. Remember I brought that up earlier, Adam? I said,
don't want to be specific here, but if we're going to go to Brian's second triangle, so I'll take away the already derived height of 524.74. We're now left with 0.555 or 419.0759. Now, yes, if we apply trigonometry, and this is the sort of point, if I resolve that triangle that they've generated using cosine, then I'll get Brian's value, because I'm trying to work out the adjacent. If I want to work out the opposite, then I get 419 as a result. Unfortunately, because this triangle is nonsensical, because it's nonsensical, as I tried to show earlier, because that 90 degrees ends up having to be perverted because the elevation and the declination angle aren't commensurate. We have to pervert the triangle somewhere. So whichever parameters we use, we can derive these 2 different answers, because the triangle is nonsense.
Which triangle are you talking about, Adam?
We're talking about triangle 2 right now. Not
Triangle 2.
Remember, triangle 1 has got a hypotenuse and an adjacent that are within 2 decimal places of each other, which is why we bother to go on with the new elevation angle to solve for the new height using the hypotenuse from the other triangle. Listen to that double speak, guys.
Yes, but if I use trigonometry like they said they were going to use, then it makes the ISS just over half a kilometer high. Because I saw it for the
over your head. Hey.
No, I'm ignoring all of that. Not that I'm ignoring you. I'm ignoring all those other things.
Disagreed with you and qualified why you're right and wrong. It depends which function you want to use. Which
yeah, but you have to beg the question with them at that point. I'm not begging the question with them. But I'm doing trigonometry, so that can't be begging the question. Because they can't do that.
Yeah.
You understand what I mean?
Yeah, but you're not doing triangulation. I think
because I'm looking for the opposite height.
Yeah,
trigonometry we're doing, not triangulation.
Well, triangulation. Hold on. Triangulation, trigonometry. That's the phrase. That's what it is. It's idiotic because what they're trying to exactly, they ain't even trying to say this. They didn't even get this far. What they're saying is, if I'm trying to triangulate an unknown position, not mine, that's resection. We're doing intersection here because we're trying to triangulate. What they're saying here is, if I don't have anybody, I'm out there in the wood line. That's where I put myself in these situations because I've been there and I've tried to do this before. Very successfully, by the way. Just to let you know, I'm certifiable in this. Actually, literally. In navigation, by the way, just to let you know. If you want to see documentation out there in Chatland, you just let me know and I'll post it. What they're doing is, it's so stupid, is if I don't have anyone near me and I can't triangulate. What they're trying to say is, okay, if I take an azimuth to a certain point and I don't have anyone with me, that I could just walk 5 feet to my left and get another azimuth angle, and then cut that baseline in half to 2.5 feet, and then triangulate. That's got to be the most stupidest thing I ever friggin' heard. Do you guys follow me with that?
That seems a nice analogy.
It's stupid. No, it is.
No. But remember that the angle you're going to calculate. So you look up there. It doesn't matter what angle you measure, right? First. And then you move 5 feet, right? And then you look there, and then you look at the difference, right, between your two views, and the difference, you calculate how much of that took up the thing you were looking at, right? And then you divide that by the thing that the difference that you were looking at, the two tracks, the differential position from your binocular vision. That then gives you the angle to put the if you divide it by 2, gives you the angle to put at the top of your triangle. That's the claim, John.
I'm not dealing with their claim. I'm not dealing with their crayon munching claim because it's stupid from the word go with the angular sizes. Did you follow my train of thought, though?
That's what I said, but I was just talking about what you've got to do. You've got to take a picture there, and you can't just measure the angles to the thing. You've got to take a picture there, overlay those two pictures, see where the crossing point is, and derive the distance on the crossing point on the object you're looking at, distinguish that as a fraction, the crossing point of the thing you're looking at, then divide by 2. That gives you your angle, right? That'll give you your hypotenuse, right? Now, you can then, even though you've got your height right now, you're then going to take that hypotenuse and use the initial elevation angle that you took when you were looking at the object, and use that and the hypotenuse you've derived from the triangle you've already got, derive a new height based on the elevation angle of the first thing you was looking at. That's what you got to do in the woods.
You're on crack. I'm not looking at anything.
I'm not on crack. Red's Rhetoric and Astronomy Live are on crack because that's what they proposed.
Oh boy, oh brother, I can't. I've seen some stupid shit and heard some stupid shit in my life, but this is just right out there. Just clobber yourself in the face with a spade shovel and then sit down on a stick of dynamite and then find a bonfire. Find a bonfire bench. This is preposterous ludicrousness, absurdity, folks. On a fundamental level. Fundamental geometry and trig. Unbelievable.
How did they beg the question and use triangles?
That's true. I didn't even touch that, right? That part of it. You're right.
There's too many points to be offended by in it.
Yes.
You get me? It is literally, it's just sleight of hand. It's just a straightforward con trick.
Yeah, but you didn't evaluate my example. You put it up in the sky. That was my other point before. I'm not putting it up in the sky because I'm a land lover. Right? I was doing land navigation and performing intersection. Triangulation, in other words. You follow that? So I'm taking azimuth angles, not elevation angles. The thing's not up in the sky. The point that I'm looking at is not up in the sky, Adam, for goodness sakes.
doesn't matter where it is. Doesn't matter what angle you get. First of all I want to know is where the two pictures, when I overlay them.
There you go with the pictures. I didn't take any damn pictures out in the wood line.
Well, how the hell are you going to find out where you are?
I'm not trying to find out where I am. I'm trying to find out the unknown point, which is not mine. I know where I'm at.
You need to take two pictures.
Oh,
One here and
brother.
one 5 foot away. That makes sense. And then overlay the pictures of the thing you want to know how far away it is. See how they mismatch. Calculate the distance
You
between
son
the
of a
mismatch.
bitch, you. You're not following my example. We're gonna have to have an intervention.
I've been opened up to a whole new world of analysing the world today.
You have. You're on these two pictures that are taken without the same equipment and then superimposing one on the other.
I can measure all sorts of shit I never thought I could before now.
Yeah. Shit, what else is there left to talk about today? I should have never watched Nathan's video this morning. We would have been dead into the natural science and scientific method if I didn't watch that video again. Or watch the video for the first time.
Yeah, but you wouldn't have laughed as much.
I don't think you're understanding Adam. Adam wants to know that if he's wants to know that what he's supposed to do if he's lost, if he can't find the height of the photograph.
Exactly, Brian. I know the height of the photograph. I'm away, son. Anywhere.
Exactly. Help, I'm lost. What's the height of the photograph?
What? Adam!
I'm agreeing with Brian.
Adam!
Yes.
We're lost, man. What are we going to do?
What the? Somebody quick, take a photograph.
What's the height of the photograph? That's what I was wanting.
Get that. We'll figure that out by somebody else taking a photograph, overlaying the two, and showing the differential between what we're taking the photograph of and the differential. Calculate that, right? And then divide it by the original angular size of the thing you're looking at, and you'll know the height.
No, you need to get this down. When I say Adam in the future, Adam, you say yes. I say, we're lost, man. What are you going to do? You need to say,
find the height of the star.
We need the height of the photograph.
I'm getting confused.
That's what I was going for, but you're not too quick on the uptake now. You had a couple glasses of
One way or
wine.
the other, I got it right and wrong. But yeah. It's all the brainwashing. It hurts. Dealing with such absolute trifle. That's all you were. There was nothing there. There's no maths there. You're just unpicking bullshit, aren't you?
Yes. Yep. We're unpicking retards that don't know their ass from a pipe wrench. They sound like they do. The really scary part, if they actually think that they're doing something legitimately, what kind of delusion level is that? That's well beyond Dunning-Kruger. I mean, we're echelons above, scope echelons above Dunning-Kruger. They got to come up with a new phrase. Yeah. All right.
Panel.
Anything else?
We haven't alluded to the panel. So is anyone on the panel? Brian excluded, because Brian butts in whenever.
Yeah, Brian butted in the whole time.
In the right, hasn't he? You know what I mean?
I didn't say he didn't have the right. I'm just saying that's what he did.
I did
go
do that.
down. Right, I'll start with absolute. Are you there? Any comments, thoughts?
This is the first.
Everybody unmuted, QA.
This is the first. Yeah, I think they are. He's unmuted. Yeah. Yeah, everyone's unmuted.
We'll reserve the right to come back then. Dank, anything to say? quiet in it in Discord.
Yeah.
Diego.
Diego L76. Comments, questions, concerns.
Move over to Miguel Souza. Anything there, sir?
Hello, I'm working. Just listen.
He just popped in here, didn't he?
Too long ago.
I was listening a while live stream, but I'm working.
All right, let me know if you heard this before. Adam!
Are you lost?
Sir!
We're lost, man. What are you going to do?
Get you hide a photograph, sir!
All right. Very well, Miguel. Go on next.
Well, before we go on, I've got a super chat from Tony Whitcomb.
Oh, thanks, Tony.
20 English pounds.
Damn.
You have to buy a house over there, innit? In the States. Anyway, Tony, been to my brother's funeral. Oh, I'll take a more somber tone.
Oh, man.
Been to my brother's funeral today. Died suddenly. Make your own mind up about that. His daughter had a collage for her dad that had a globe drawn on it. I pointed it out that it's a thought experiment and blue heads. Oh, yeah.
Oh, wow.
Yeah. First of all, commiserations, Tony, and second, time and a place, brother.
Yeah, I'd have to agree. I concur with Adam. But
anyway,
appreciate it, Tony.
Where were we? Raleigh. Raleigh. You there?
Raleigh.
I am here.
That was definitely the question.
Next one, floor's yours. So.
Floor? I get the floor now?
You can if you
Is
want.
the floor flat? Or is it a globe?
Shut up, Adam. Go ahead, Raleigh.
Yeah, I'm watching some Redditors that keep telling us all this garbage. Just can't believe it. It's like nobody learns physics anymore.
Nobody knows what physics is, dude.
They think that one guy says, oh, it's because science has rules. And science? You mean physics? Because science has their own set of rules.
Yeah, it's called the scientific method.
And your experiments will be all different for every single different hypothesis you have, right?
It better be.
There's no one rule for everything.
No, that's not rules. That's just a method to get to the answer, the cause and effect question.
Exactly.
All right, cool. Refracted. Oh, we got refracted curvature in here, Adam.
Evening, John. What are your thoughts, mate?
I'm offended that you all have hand waved the hide a photograph. I don't know what to say about this. You letting that one slide by.
I didn't let it slide by. I was all over it.
All over hand waving it.
I wasn't.
The importance of the photograph is just.
Yeah. All right. I got you.
Sorry, that's probably. I can't believe anybody made
You're chopping, dude.
argument.
Dude. You're chopping, man. Bad.
Yeah, I thought it was me.
No, it's not you. He's chopping. Drop out and come back in again, John.
Oh, and we've passed D Rose already.
You have to go back up to D Rose while refracted curvature drops and comes back in.
Yeah, well. D Rose, what are your thoughts on this evening, mate?
Yeah, I had to step away to deal with the children, but from what I gathered from the last time I spoke, like I said, they're up to their bag of tricks, new tricks, old tricks, innovative tricks, anything they can do to try to push their narrative. And unfortunately, their subscribers who are going to be loyal to them anyway, disciples, are going to eat that up like, yeah, see? That's what I'm talking about. That's science, yada, yada, yada. But fortunately, we have this, this panel, QE, you guys, you, Adam, Brian, everybody, that can, pretty much unpeel this so you can see the rot in the core. You can see that the pit is defiled.
Yeah.
And hopefully this will get around to the same amount of people. We spread this on Twitter and everything like that in order for people to see the truth. Because these guys they're a bunch of deviant, dastardly dimwits.
Yes.
A nice bit of alliteration to end on, Deros. Thank you.
We got Roto
Gone
X
again,
left.
John.
We got Roto X left before you're ready, Adam.
Yeah, hey guys.
Hey.
Great show. Didn't get to see the video in question, but listening on Discord. But Shop Talk, I think it's great. Talking about the topics like the distance to the, stuff like ISS is out of the fundamentals a little bit. I think it's great to kick around as a Shop Talk to expose, really, I mean, this kind of thing, it's a template over and over where you see this convolution of mathematical guile, right? So that's the trick. Showing, how the button works, the pulley is good. So this kind of exposure is important, but it does bring the topic to what isn't, like the ISS. So, two sides of the fence on this type of topic for me.
I hear you, man. I got you. Right? Because we beg the question. I don't often do this. It was so disturbing when I first seen it, such a belly laugher, that I just remember my in lieu of caveats. In lieu of, the ISS isn't in 10 to the -6 torr vacuum. So if it's not there, it's not there, period. That was probably the biggest one. Yeah, but we look past that so we could deal with the abject bullshittery of pretender clowns that think they're like McBooger Eater. What did he say at one point? He goes, like a high school trigonometry, like Sakatoa, like that is supposed to tell us that he knows what he's talking about. That cracks me up. Those are just headlines because you're now going to get grilled. And you ain't going to be able to stand because you're a pretender clown fraud McBooger Eater. You're the McBooger Eatingest McMoron this side of the McWest. I already established that back with the signature numpty clips for about 30 minutes, point by point by point. These were fundamental, just basic knowledge points you couldn't get right. How is he even still out here? Did he respawn?
I'll round out answering Roto's question. What is the ISS? I genuinely don't know. Hopefully the point of tonight's demonstration, I hope people can maybe come to the conclusion that if we are going to find out what they're doing, where it is, probably the way to do it isn't to have two dudes with different optical devices, 1.1 kilometers apart, taking a picture, overlaying those pictures using the angular size of the path divided by the angular size of the moon, which is different in the two pictures, coming up with a ratio and applying that ratio to the angular size of the moon, divine an angle the top of a triangle so that they can calculate the hypotenuse and adjacent, which are within 2 decimal points of each other, the same. Then take that hypotenuse, apply it to the elevation angle that you applied to the moon whilst you were watching the transit and taking the photo, calculate a new height, which argues with the previous height you'd previously calculated based on pixel ratios, divine the height of this thing we don't know what it is. The two very different questions. What it is, how they're mugging us off, what they're purporting it to be, is one thing. I don't think we'll ever find it out on this level of retarded logic.
Thanks, Adam. Is that your go time?
Yeah, it's me done, bro.
All right, guys. Thanks for coming. We'll catch you on the flip side. QE out.
There is no triangulation in celestial navigation, so it is actually triangulation. There is no triangulation in celestial navigation, so it is actually triangulation.
With celestial navigation using a sextant, we're not triangulating.
So it is actually triangulation to the GP. So you can draw it on your chart, draw a line there, and then you do it for all three, and you get your intersection. So it is actually triangulation. There is no triangulation in celestial navigation.
With celestial navigation using a sextant, we're not triangulating.
So it is actually triangulation.
Are you serious? Are you
The double-speaking McBooger-eating, ball-tarred bum-sniffer wouldn't know what the sextant or celestial navigation were if they climbed up his arse and started kicking footballs wrapped in concertina wire.
Just when I think you couldn't possibly be any dumber, you go and do something like this. And totally redeem yourself!
I think the sun is a physical object, and I think it is solid enough.
What the hell did you just say?
I think the sun is a physical object, and I think it is solid enough.
Say what?
Yes, a gas giant bounces radar.
How in the world can a
gas giant
be
solid enough? So yeah, I don't know.
You dumbass cracker.
You are so dumb. Damn.